we be dividing percent like 0.1, 0.7, 0.1, and 0.1. Based on this 0.98% that is retained.
No, but look, okay. So
F6
say
just changed.
Sudarshan has 100 rupees now, right?
Yeah.
Right. If I give away if I save 0.1%, that is 10 rupees.
Yeah.
If I give away 70 rupees, right? I'm giving away 70 rupees. So now I've spent 80 rupees. Let's just say I've spent 80 rupees. Yeah.
Yeah.
0.08 also. Okay. Yeah, now it makes sense.
Yeah, the
Everyone
0.02 is actually whatever Sudarshan has.
saves.
he-
Yeah. Yeah. This makes more sense also.
the 2% of that, right? Yeah.
Yeah.
So I guess in the end, that's what I thought. Like in the end, because the king is giving them 10% and he's collecting 20%, in the end, the net flow is only 10%, right? I mean, the king is only in the end collecting 10%. Is that the way it is?
Okay, guys, let's go slowly. Now look at what has happened to the sheet. Look at the matrix and look at what has happened. I'm going by whatever you were suggesting, that sum should be 1, right?
Yeah.
Sum is 1. No new money is printed. Okay.
Okay.
So what's happening?
All the money is converging to the government.
This is similar
The
to that
king gets all
gambling.
the money. Wow, okay.
Yeah. It's similar to the gambling theory we were trying to talk about.
Correct. No, but then I'm taking a very small amount from everyone.
Yeah.
All right. Now what I'll do is minting money part. If I do it, see what happens. What happens?
Everyone will have infinite. Okay.
This is called inflation.
Mm.
Correct? Simply money will increase tremendously.
Yeah.
Right? That's why they say we should not have pension schemes like this. Because pension scheme, ultimately you will not be giving money from your pocket. You will be compensating for the deficit by printing more money. Right now, it will have an impact after 10 years. Insanely, everybody will be rich. By rich, I mean lot of rupees. Whatever 1 rupee would get you long back, 10 rupees is not getting you that thing today. While in US, $1 is $1 from a long time. Coffee is what? $2 in US. Till date, it is $2 even after 10 years. Maybe little bit plus or minus. But then in India, coffee was 1 rupee when I was in high school. Now it is what? 15 rupees. I'm not talking about coffee day that you should put another 0 next to 15 there. Right? I'm talking about an ordinary cup of coffee on the street side. Right?
Yeah, but okay. What happens if they don't keep all that money? They don't think about keeping all that money and they're spending from it. What happens then?
Coming in. See, whatever you say can be translated to the matrix.
Yeah, exactly. I understand what I want to do. I want to do is I'm getting in whatever money I have, from that only I'm going to give to the pension scheme. So that is nothing but saying the last entry, which is
government will be at loss. I mean,
that's what I want to see.
0.96. 0.96. I can do that. I can do that for you. One moment. So where is it? Okay. So what we should do here rather is okay. This is all good. This is 0.01 only.
No. That is the total, sir. He tried to put the total in every column.
Oh, totally is putting, is it? No. This is now a 5x5 matrix. This is government G here. Maybe you can put the total in the last column here.
Okay.
Sir, then who is K, sir?
King.
K, sir.
Pardon?
No,
is-
yeah, we have both the king and the government, like just in a.
Oh, I'm so sorry. I'm so sorry. I'm so sorry. Please remove it. Please remove it.
Yeah,
It's a mistake.
Chetan, let's not manipulate the matrix now. It'll get just confusing if we just change a lot of things at a time. Yeah.
Correct. एक minute रह जाओ. Let me just change it. Just give me a second. So sum is important. I understand. So sum को यहाँ पे लिखते हैं. So this should be then 1. Okay. I take 1% from everyone. And let's say I give 0.05 to everyone. Okay, this is right. Correct.
Chetan, can we look at this thing? We're looking at your screen. Yeah.
Looking at my screen, is it?
No, we're looking at Chetan's screen. Is there another? Are you sharing the screen, sir?
Yeah. I will share my screen now.
Yeah, that'll be better. Yeah.
Is it done?
Yes, sir.
Yeah.
Yes, sir.
Okay. There's all 1111, which means it's right. So I'm giving 0.0, which means that government is being faithful here. It's not printing more, or rather minting more coins, right? So sum total is 500, as you can see here. Correct. Now look at this. The government is indeed getting some money. And government is converging to 166. Despite taking a small fraction and then giving out another fraction. Right? Now the point is, taxing is all about. Okay, so now let's do one thing. Let's only levy income tax, not social security, because social security, the problem here is that I'm giving it to everyone, right? So let me do 0, 0, 0, 0 and 1 here. I will be eating up everything. Correct? कुछ तो देना ही पड़ेगा.
Yeah.
So I'll give very, very less.
Number of steps would be more, I guess, right? But it will eventually be the.
See, I'm giving something, but still that giving is not enough. So let me write giving here. One second. Give me a minute. Sum total 1 barta, yeah.
Yeah, you can make B2 as 1 minus B6, right? And then do the same thing for others. Is that what you're trying to do? I'm sorry.
See, if I give a lot and take less, right? I'm converging to 12.19. Okay. Let's say taking is always 0.01. Okay. See, the problem with this is I think we should deduct that from the, I will do that. Wait. What was this supposed to be? 0.9. Just give me a second. This was, okay. This is always this,
Sum of 3, 4, 5 minus 6, right?
yeah. I'll do that in the diagonal. Okay. Sum has become 9.8, 7, 8, 9, 10. Okay. So this minus this always. Perfect. And then this minus this.
In that case, you have to make the first entry as 0.2, right?
No, sum I'm managing to.
So in this case, we are just taking the tax that original person is retaining only. Like you did for this B2.
No, I'll tell you what I'm doing. I'm just
Taking out the savings.
Yeah, taking out the savings, that the same thing. That is a person is retaining now.
Not really, right? What does B6 is nothing but which is 0.01. It's saying 0.01 of what I have, what Sudarshan has is giving. Total, his Sudarshan's total money ka 0.02 is giving.
Yeah, but that thing, yeah. But that is of with respect to the saving now. Like
No,
as
we are just saying, see, we're just making the savings as what is left after paying tax. But tax is levied on our entire income. You understand this? Because that 0.02 is being multiplied with 100, which is your 100,
Yeah.
right?
Yeah.
After paying tax, what is saved is only 0.07. That is what this means. It's not the other way around. You're not confused that.
okay, I've hidden all the rows so that it's easy. So giving, if I give 0.05, it gets updated automatically. Okay. It converges somewhere. Okay. If the giving is 0.1, it converges somewhere. Giving is 0.2. See, barbad ho raha hai, government, right? 0.3, 0.4, 0.5. It's getting negative. 0.4. Taking is 0.01. Doesn't work. You see, 0.2, if I take. Okay,
Sir,
so what is happening here? I'll tell you exactly what the Excel sheet is. The Excel sheet is a very faithful way of running the government with no minting of money. Okay, so as you can see, sum is turning out to be +1 always, right? But then it goes to negative balance. So we should ensure that everything is positive. You know what I'm doing? S to S, read the formula here. 0.1 minus B6. Okay. So
everyone should save enough to pay the taxes. So maybe we should make sure that the diagonal entries are at least as much as how much the government is taking, right? Because you cannot pay taxes that you don't have, money you don't have.
no, then it will be 0, no, automatically.
No, when it became negative, that was because
Yeah, negative means you're on loan, basically. You're on negative balance.
Okay.
Yeah, you keep giving and you don't have any your net worth is negative, but you keep transacting basically. Right? Okay, so Sudarshan does not have anything, you see. I mean, that's the diagonal. It shouldn't matter. See, whatever it is, the diagonal is I retain 0, but at the end of the day, I keep getting money. You see, Sudarshan's value is 88 lakhs. Right? Ideally, the best way to handle it is giving and taxing should be such that the money is distributed equally amongst everyone. and government has less. Let's reduce the government. Let's see. Government gives 0.02, then government earns a lot. By the way, guys, look at just the last row. Rest of it is to be hidden. Okay? I have hidden everything. As you can see, after 21st row, it is 1000th row. Right? Okay. Now, where are we right now? Those who are still here, we are trying to model a matrix. Using a matrix, we are trying to model a financial situation of a country. That's it. And you see the power of doing it using matrices. Matrix is directly applied here, right? Okay. So giving is 0.02, it takes 0.01. Okay. This is decent. Government earns 55. But you see, S and B are more or less the same. Is there something that will make S and B earn differently? Can you make B earn more than S? Impossible. Impossible, right? As long as the is not disturbed, this is impossible. What should government basically do is to tax more for B than to S. Then B can see B is now making 59. S is making 75. No matter what is the give and take, if it's uniform, S will remain richer than B. Right? That's why you should have different slabs of income tax. You should come here and change this 0.2, 0.2, 0.2 to 0.1, 0.2, 0.3, 0.01, whatever, or maybe 0. Right? Okay. A government that doesn't take at all. Government बर्बाद हो जाएगा, obvious. Right? Takes very less also. Right? Is able to manage as long as it gives. Right? Okay. All right, go on. Tell me. Any questions so far?
When giving and taking is equal, it's just like the government doesn't like exist, right? It's just like where this
Yeah. No, basically,
whatever is given is taken, right? Yeah.
yeah, 1% is taken, 1% is given. This shouldn't matter at all. It's like equal amount is taken, equal amount is given. Government के लिए कुछ नहीं है, right? But it matters to people to an extent. Right? I take 1% from you and give you 1% of what is collected. Okay. For instance, look at this. If you'll see the difference. Look at how much you are making. 87, 124, 65, and 122, right? If I make this 0 and 0, which means I'm not giving anything. Right? 87, 124, 65, and 122. Because of the convergence. This is the eigenvalue. The eigenvector. You will come there only, ultimately. But initial values, you will see there's a huge difference. Look at this. First 20, just observe the first 4 rows. Okay. Is this converging faster or is this converging faster?
The second one.
0 is converging faster, right?
No.
0, 1.
87. Yeah. 3, 9 is coming in 7th. 3, 8 is coming in 9th row, right? Five, 4 is coming in 8th. There's a difference, no? There's a small difference, right? 87.54. 87.38. There's a small difference.
Yeah.
Yeah.
Maybe it's delay in convergence, that's all. Because of minus signs in many places.
Yeah.
Okay, let's do one thing now. Let me go and vary these things. -1, -0.1, 0.2, 0.3, 0.2. Okay. I'm giving back, let's say, this is variable slab, guys. The idea is who was richer here. Okay, so let me just 1 second. My keyboard came off. Okay. Look at this. The idea was if you made it 0.01 everywhere, you made 0.01 everywhere. This was the status. Who was richer than whom? So look at Sudarshan and Aditya. Aditya was 1.5 times richer than Sudarshan. Correct? So how much should I tax Aditya? See?
Hmm.
Yeah.
It's sort of equalizing, you see. No, but why is taxing Aditya
But-
reducing Sudarshan's money also? That's because
Yeah.
they are transacting with each other. If Ambani becomes poor, probably
Everybody
Samsung will
will-
become poor. Apple will become poor in India. Apple sales will go down if Ambani is not there, Reliance is not there, Jio is not there, right? Okay. Tell me how to make everything the same. See, I can always give back the money, right? Tell me what should I put so that everything becomes same. Let's engineer. Tax the second person more, no?
Yeah,
No.
second and third person more.
Okay. First and second equalize हो गया है ना?
Hmm.
Okay. देना भी चालू करेंगे.
B has to be given money.
B has to be given. No,
Third.
B has to be given money. Third. Okay.
Yeah, yeah.
Okay, guys, manage this. I mean, try to come. Try working on the 6th row and kth column. It's difficult. You should now solve a brilliant optimization problem. Solve it and make everybody's salary the same. Go ahead. Maybe one person can do it. Sri Vinay.
Yeah. Sure. Do you want me to share my screen? Will you be
No,
available?
it's visible here only, no? So it's
Awesome.
okay.
Okay.
So if we need to give more money to S because he's retaining the least.
Yeah. You want to give more money to S, is it?
No, I'm saying that we should give more money to S because he's retaining less. But
Okay.
but we are having two which are negative. That is A is on like deficit and M is also on deficit.
Okay, there's a logical way. Let's see when I do the Sri when I do the gradient descent way. I mean, he's slowly changing and then trying to equalize it.
Yeah, so I need to tax B a little more. Let's say 2. Okay, 2 is not changing much, so maybe 8. Yeah, this is coming close.
Super, super. So now give proportionately more to everyone so that you see ideally your money should become 0.
Which is this, is it?
Yeah. King's money should not be so much.
Mm-hmm. So I should start giving more also. So if I equally give more, will that, okay, maybe that will not work.
No, that will not fit. So it should be 1:5. 1, 1, 5, 1. So 0.1, 0.1, 0.5, 0.1 though.
0.1, 0.1, 0.5, 0.1. That's already, oh, so you want 0.5 here?
No, that will add up to 1 only. Nothing to worry. See, K ka column में 0.1, 0.1, 0.5, 0.1 though.
Key
Yeah, that
column,
is
you
true.
want 0.1, okay. So you want to increase this, right? Okay.
Yeah.
0.1,
That is the giving, right? 0.1, 0.5,
0.1.
0.1. See, government के पास बहुत कम हो गया. Huh? And everybody has more or less the same money.
Yeah.
Now engineer this. Now ensure that the distribution is.
Maybe a little more.
Good. So you have, you have drastically reduced 94, 93, 95, 93 is amazing. But then government still has a lot of money.
They're keeping, yeah, so I'm taking this much. So from whom I'm taking, I should not give back so much. So I'm from A, I should not give back too much. Okay, I'm not giving back too much. From 3, I'm giving back quite some money. So maybe okay, that change is too much. So maybe 4, 5. Yeah, and from S, I am taking 0.05 and giving 0.1, is it? Okay, maybe I take a bit more and give less. Or maybe I'm going in the wrong direction.
From B and M, we are taking.
Yeah, this is
similarly.
very close. Very close. Yeah, very close. All the values are on 92.
Yeah, but then government still has 132.
Government still has money, right? So who can I take? Sorry, give back lesser, right? For this I'm giving back too much. Sorry, I want to give back a lot, right? So maybe I will reduce taking from this person 3 and increase. Is that going in opposite directions? I'm sorry. Yeah, that's going in opposite direction.
Anyway, you guys got to know the question, right? I mean, this is actually tough to solve. This becomes a simple optimization problem, and maybe only gradient descent will work. Okay. Although see, what should you minimize? You will minimize the standard deviation. You write that complicated equation. Answer is standard deviation. Fiddle with 0.1, 0.4, 0.3, 0.3, and 0.13, 0.1, 0.45, and 0.1. Anyway, we'll see more of matrix factorization coming and helping us in this simple matrix problem of stress and happy tomorrow. But you guys carry on. You guys carry on and discuss this. Discuss what's happening here and how can you model it and stuff like that. Okay? I'll make a move.
Yeah.
Any questions? You guys can discuss. And maybe I'll take a couple of questions if any. No, right? It's only exploration right now. Correct?
Yeah.
Take care. Bye-bye.
Thank you, sir. Have a good night.
Thank you. Good night.
Thank you. Good night.
Good night, sir.
Thank you, sir. Okay, who was sharing the screen?
Sir was sharing the
Oh,
screen.
Okay, okay.
Also, what was the meaning of that negative values in the diagonal and
Yeah, maybe we can
It's like
discuss
taking a
that.
loan. Yeah.
Okay, should I share the screen? Okay, let me
Yeah,
just
sure.
not this.
Yeah, assignment submission up. It's
Okay,
deadline, man. Go submit.
already done.
Okay, okay.
Okay. So yeah, who was asking the question?
Yeah, he was asking what are the negative values in the
Right,
uh,
right.
diagonal mean.
In this question, I didn't get uh, quite a few points. Uh, one view from this distribution that I get is like we are just operating this matrix to a certain input and producing a certain output. One thing is quite clear.
Mm.
But that case, we can also visualize it as column combination of columns also. One idea is that. But now now the this when we were adding initially this point one that is point one of k, and sum of the values in the column vector was becoming more than one. That I didn't exactly understand because a person cannot mint. We can say the king has right to mint the money, but not that person. So where the extra certain
Black
point,
money.
yeah,
No,
something
I think
like
that's
that
why
is
Sir changed it, right? After that, he wanted each of the members to only shell out one. So that's
yeah.
why we changed it. That's why.
In that case, we only change the diagonal elements. We only subtracted for the diagonal elements.
Mhm.
And in another view, what diagonal elements were presenting is the portion that individual was the portion that money was flowing and he was retaining, means he was saving for himself.
Mhm.
And in a way, we were only taxing the amount, the money that an individual was saving. Am I correct?
No.
What does
Any,
subtraction from the diagonal means?
yeah. Anyone wants to maybe clarify that? Does anyone understand
didn't
his
get it?
question?
What does subtracting for the diagonal mean?
So basically what he's saying is, uh, in each diagonal, you are actually subtracting, like say for B2, so you're subtracting B2 with K2, and that's happening with everybody. So I believe that's some sort of an income tax thing, where you're basically taxing what your savings is.
Yeah.
You're saying saving now. The
No, no,
saving
no.
equal to
Aditya, yeah. Aditya, you made a statement, right?
Yeah.
Actually, the taxing is actually on your entire amount, what you have. Think about it. It's not only taxing on your savings. Your income tax is based on what you have, right? I'll maybe make it clear in a point. Chetan, is it okay if I share my screen? I just want to use the sideboard.
Good.
Yeah, is my screen visible?
Yeah, it's visible.
Yeah,
Mm,
it's visible.
1 second. Okay.
So actually, like you have, say you have 10 rupees, then the person who has 10 rupees has to give, if it's 0.3%, 3 rupees, and then person who has 100 rupees has to give 30 rupees, right? So not actually doing 1 minus 0.3. You're not giving 0.7, but you're giving.
what I understood from this taxing thing that the king was taking. I just subtracting the this. I just leave the equal tax on all the money that was flowing, whether it was from A, B, whatever the money was flowing. But here, why would we not equally taxing, decreasing all the amounts equally to their distributed proportion, but just diagonals?
I guess the diagonal was done just to sort of make it equal to 1. We could have done, we could have deducted from each of the row as well. What is it?
Exactly. Yeah. So, am I audible? Yeah, okay.
Yeah,
Cool.
yeah.
So that's the thing I want to mention. See, just because the formula for save was so this is the so this happens to be diagonal entries. I'll just denote it here, right? What every person, okay, whatever I'm saving is actually lying on the diagonal. You can keep that in the back of your mind, right?
Yeah.
What I'm saving, okay, what I'm giving, let's start from here, okay? Let's take one of the columns. Let's say I am Sudarshan. I like being sir. Anyways, so what if this is my my like distribution, right? What I'm doing. Let's make giving equal to 0.05. Just so tax is 0.05 for me, not 0.1. Let's start from here. I see that it's only changing my savings now, but if you think about it, right? How much am I saving? 0.05 of 100 is 5 rupees. How much am I giving? I am giving away 0.7 of my money, 0.1 of my money, and 0.1 of my money. That's nothing but saying I'm giving
90%
away
you're giving.
90% of my money. So I'm giving away 90
90
rupees,
rupees.
right? And my tax is how much actually?
5.
Which is nothing but 0.05 of, is it 5% of my savings?
No, it's
Yeah.
5% of.
It is 5% of the entire
100.
amount I had, right?
Yeah.
Savings, we were just presenting it as what, so what proportion I'm giving to save. So when we're doing the formula, the value is actually proportion of tax, right? 1 minus proportion of tax. I think that is the formula, right? Maybe 1 minus proportion of tax. That's what you need to remember. It's not 1 minus, I mean, this is not presenting any what absolute value. It's trying to say what proportion of my money.
I get it. This is basically the percentages, and the value that you're subtracting is itself a percentage.
Exactly.
So we're not talking in any absolute terms.
Exactly.
So basically, you're reducing 5% with 0.05, which would be something around 4.95.
Yeah. Did Ankit, did you understand this, or do you want to maybe clarify any other doubt you have here?
I still didn't get just can you diagrammatically show? I'm like
Sure,
that.
sure.
Going,
This is better. This is better. If I do this diagrammatically, okay, I have 100 rupees, right?
Yeah.
Let us say we'll start with tax. We will start with giving tax. Okay. Let's
Yeah.
start with giving tax. This is my tax. My tax is 5%,
Yeah.
which is 5 rupees, right?
Yeah.
5% equal to 5 rupees because it's 0.5 into 100, right? Let me put the factor here. 100 is, so 100 is a factor for everything, not only this. Even if I do this, this is my give. So let's say I'm paying my taxes first, right? I paid 5 rupees. How much money do I have left?
95.
95. But I am only going to give how much percent of this money? 90% of the money I had, I'm going to give. So this money is only after you calculate. So don't think about this, right? Whatever input I had, I'm going to give away 90% of it, right? I had 100 rupees, right? If I do percentages one by one, obviously the percentage that it is acting on will change. So what I'm doing, I'm fixing my left-hand side. I'm fixing, okay, the total money I had was 100 rupees. I am allocating 5 rupees for taxes, allocating 90 rupees for giving, allocating 5 more percent. So don't think about giving tax, think about allocating. right? Allocating will make it easier, right? Allocate, that's better, right? Allocate to tax.
What I was considering in this case was like I am having 100 rupees.
Mhm,
I have paid tax of 5% to the government. Now
mhm.
I am remaining with the 95 rupees.
Mm.
Of the 95 rupees
No.
that I have, I am retaining a portion and giving a portion.
Mhm. So,
So
okay. If you think about this in terms of how we started from this, right? Everything is happening simultaneously.
yeah.
That is what you want to remember, right? When
Mhm.
I'm giving myself 5%, let me write it as 5% itself, right?
Yeah.
I am doing it at the same time I'm giving tax of 5%, right? And I'm doing it at the same time I'm giving away 90%, right? So it's happening simultaneously.
I have a better analogy for this.
Sure, go ahead.
So if anybody is familiar with salary structures,
Mhm.
so you have a basic pay,
Yeah.
and whatever perks that you get is based on your basic pay. So you
Mm.
get a house rental, HRA, that is some percentage of your basic pay.
Mhm.
You have your TDS that is also collected on some percentage of your
Yeah,
basic pay. So think of that 100 as your basic pay,
exactly.
and everything that you're taking out is basically based on that your basic pay. That is your 100 rupees. Or you could take it as 100%, whichever feels better.
I think I will need to put a lot of thought in this because I don't know, but when it's come to the financial terms, my mind sometimes blocks something. Don't know why, but
That's
that's
okay.
mm.
Oh, it's 12 o'clock, is it? Wow. Didn't realize. Okay, you want to go back to the Excel sheet, maybe?
Yeah, let's start with the starting from the starting. Let's start from the very beginning. Then we'll discuss it. Maybe then we'll have some better idea.
So
No,
I
no.
had just one question regarding the taxing part.
Mhm.
So the ideally what you want is you want everybody at some point in time be reaching some sort of equilibrium, if not equilibrium, but in a state of an equilibrium, almost a state of equilibrium, right?
Mhm.
And
Yeah.
you are also providing some sort of subsidy or say government spending in the economy.
Mhm.
Now, while you're doing that, and you're obviously taxing the richer more and the poorer less, and giving out benefits to poorer more, uh, richer less, right?
Yeah.
But at the same time, you also need to take care that the particular person that you're taxing doesn't end up being in negative, right?
Yeah, you can never tax anyone negative. You're right.
So
I mean,
if you
taxing someone negative is very similar to saying you give them subsidy. I mean, I don't know. I don't think we should think of it
no,
like
no, no,
that.
no.
But
I'm saying that ideally you don't want to tax somebody so much that the person's balance sheet becomes negative. Do you get what I'm saying?
true. Yeah.
So you want the taxation to be where let's say you're taxing the rich more, but you don't want the rich to get in loan, right?
Yeah. Those are the real world problems, right? You're right. Yeah.
Mhm.
So in this sense, right, when you look at this, where is the convergence happening for all the people?
Was around 92, I guess.
Yeah, 92 was the soft spot. But if I reduce more amount going to government, right?
Mhm.
If I say, if in the end government also keeps their 100 rupees, And I want to equally keep everyone in the same, which is saying I want to remove people from poverty to become,
You
have a
basically
middle.
want government and the people at the same level.
Yeah, yeah. Not okay. I would think of it the other way, right? Government is still running because it has some money, income and expense all the time.
Mhm.
But the people are also, if they were in different what do you call that?
Different
Slab.
strata,
Yeah,
but you
yeah,
want them to
exactly.
somewhere reach at the same point.
Exactly,
Parity.
exactly. Yeah, but disparity, this should be removed completely.
Hmm.
Yeah, you're right. So yeah, you would not want to increase the tax of someone too much. Yeah, then we can just keep a threshold and be like, okay, we cannot, we should try not to tax someone more than 40%. Like I think that is the maximum that you can tax. So yeah, let's make sure we don't make this more than 40% just to keep it in the sense of
Real world.
yeah, real world. One thing I see is we're taxing B 30% and we're giving back like 45%, right?
Yeah, that was
Yeah.
what I was saying. In fact, even after giving B 45%, the B is converging at a slightly lesser value than L.
Hmm.
I guess it is maybe partly due to the dynamics.
But
between
again,
B
you
and
are
L.
But this is due to the fact that
what you are.
it's about the
Yeah.
pattern of B spending.
Yeah,
No.
like the overall
You-
distribution between B and with the other like SA and L.
What you are giving out to B or anybody is the percentage of the king or the government.
Yeah.
So it would not be appropriate to say that okay, we are taxing 45, we are taxing 30 and giving out 45. It's not like that we are giving them 15. No, fine.
You're right, you're
40,
right. 'Cause
45
depends on the
45
proportions.
Yeah,
proportions.
I to reach almost the equal equilibrium state, I think the net spending of each point and net saving should be means all the entities should be competitive that are performing well, that are just means there is a balance between this spending and means outgoing and incoming and savings. And in that case, can we see it like
Sum is already here, my bad.
this is 0.9.
So you're trying to say this two values has to be kind of equal?
No, what I want to say is like if you see that for the S case, just I'm just changing a color for a bit, and let's say this thing and the amount of money that he is getting, this is also 0.95. So a sort of equilibrium is there.
But oh yeah, but okay.
In that case, if each entity is performing, if we are balancing this two sides of each the entity, then I think that equilibrium state will be attained.
But
That
you're
I'm
right,
saying.
obviously. See, but the point is you can't change the way people spend. You will let people do whatever they want.
Yeah,
But you can only change how you are going to tax them, how you are going to give them more
but
money and less money, right?
No.
see, now we can
Okay.
use this anchor points now. This king, what king is doing, because only he has the right to subsidy or tax.
Okay.
And
You're right,
we
maybe.
can anchor these 2 points to make this balance out at both the ends for each entity.
No. The thing is that we should not consider there is no capital amount. What we are trying to model out is the intermediate iteration steps. For example, everybody was having 100 rupees, but everybody, for example, S was having 100 rupees. It does not mean that S will always have 100 rupees. It's a dynamic sphere. We cannot say that, okay, make a, do a balancing act and
No, I'm not saying that make just point as balance. I'm
every
saying
all entities
if
balanced. I
if
understand.
all the entities are like some sort of
Yeah,
balance.
then you'll just stay with 100 rupees. You'll keep giving out 100 rupees, taking back 100 rupees. You're right.
Yeah.
What? Okay, yeah. I think even Nishan is still trying to do the same thing. I'm starting with 100 rupees. You're saying whatever is going out and whatever is coming in is equal. So everyone is always going to stay with 100 rupees.
Yeah.
But we know that doesn't work that way, right? People shell out more money and I mean,
No, no,
is
the
that
thing
where
is,
we want to reach? I'm not sure if that is where the
no,
answer lies.
Srivina said a very important thing is that we cannot change the spending habit of individuals. Fine. That is not in our control. What the thing which is in our control is the government make policies. Either they reduce or increase the taxation, or either they announce subsidies or take away subsidies. Fine. The thing we can vary is government's cells,
Oh,
and that is fixed. The expenditure, the nature of expenditure is fixed. We should not, we cannot make a balancing act out of that. Fine.
That's quite correct also. Even like if you see normal market structures, it is actually the policies of the government that influences let's if I take everybody as equal strata, then it influences everybody's purchasing decisions.
Repo rate,
So
reverse repo rate, government decisions, right?
so if government tomorrow says that, you know what, we're going to print more money, and then we're also going to let's say increase the interest rates, suddenly everybody will start uh, reducing their purchase patterns.
Sorry, guys. I'm so sorry. I was just, yeah, what Ankit said, I was just trying to do that. So each each column sums up to 1. We already know that, right? Because this is satisfied here. What if I use this point to make this sum also equal to 1? I mean, I can see it already going towards 100 and everyone will have the same thing. But yeah, I think that is the point, right? Is that the point? I don't know. So wait 1 second. So this would be sum of 0.86. So I would need 1,4 here. And yeah, we have reached
Perfect equilibrium.
yeah.
But the point I was trying to make is that we have made adjustments in individuals' expenditure, nature of individuals is spending, fine. But what is in our control is the government's policy to give away or take away.
Yeah, that
money
is what
from
we
people's.
changed. Yeah, that is what we changed. Remember, I changed only this blue part and this green part, which is
Yeah.
nothing but the government. Actually, this is not king.
No, the question which comes up afterwards, I am understanding that you are only changing government's cells, is that can government individually make some such a tax or give subsidies? It has all, government will always give to a bunch of people or a group of people. A policy cannot be tailor made for every individual.
Exactly, but
So
yeah,
you
so
can
that
see all these 4 or 5 people as different group of people having similar expenditure or purchasing patterns.
Fine. So what we have done is that we have made and that is possible only if we are giving and taking away the same amount of money, right? This is what Ankit suggested, isn't it?
yeah, not giving and taking away same amount of money. See, If I was
The
giving and taking away
question-
same amount of money, we saw that happen, right? We were taking away 0.1, 0.1, 0.1, 0.1, and we were
One
giving,
more thing of saving now means
yeah,
like in an example, sir said that a balance point is reached when they are means it is the all the complete system is shifting towards equilibrium uh, after certain iterations. That is due to certain things, and that certain things is might be the this weights of this how means comparison between these things means inward, outward, and the saving. There should be something. I'm not able to pinpoint exactly.
And what we did, what is this? What does this state show? So the sum total is one here, and the sum total is one also on the row wise, isn't it?
It is just showing that the same amount of money is going in, same amount of money is coming.
yeah.
For
So
individuals.
Sudarshan is giving
Yeah.
away 100% of, say,
Somehow he's giving away 100%, and somehow he's gaining 100% as well, isn't it?
exactly. He's whatever he's
100
giving, he's getting back.
But now
And we are making sure by
also the amount of money that he is retaining.
Yeah,
And
see, that includes this. That's what, yeah, that's what he's trying to say. See, this includes what Sudarshan, this cell includes what Sudarshan is keeping, he's saving.
Yeah, right.
This includes what he's getting from A. This includes what he's getting from B. This includes what he's getting from M.
Mhm.
What I'm saying is, if we give him the same amount that you know,
He's giving away.
not, yeah,
He's,
exactly what, yeah, he's giving away.
He's giving away in columns. So what he's
Yeah,
giving away is eventually what he is being given
yeah,
by the government.
yeah. Like,
And that is
difference
achieved
is
by
being covered. Yeah,
and that is achieved by
changing gesture policies, right?
of course. You know, in the language of mathematics, what we have done so that that is achieved.
Mm,
The sum
change
total,
the,
we have maintained the fact that the total fraction sums up to 1.
Mhm.
Total Sudarshan's, you know, expenditure and spending. No. What do we say when he is
Savings.
given
EMF.
savings and income?
Mhm.
Fine, both of them are same at end of
Yeah.
the day.
What if I start with different numbers?
It hardly matter.
No, will it converge is my question. 50,
Just
150,
90, 90, 90.
200.
Okay, but there is a catch, you see, you know, what where we started, we are not reaching there. Oh, no, we are reaching to 100 only, yeah? We are reaching to 100. Okay,
So even if you were poor, right? If you were M, sorry to, I mean, even if you had less money to start with, because of
this arrangement, eventually the property gets distributed to everybody. Equal property gets distributed to everybody. Equal resource of a country is allocated to every individual.
Yeah.
So what do we call this thing? One, the sum that is coming out, the sum of fractions that is coming out to be 1. What do we call it? Column wise and row wise.
I don't think so you can call it like that, that equal resources being distributed. I think you can call it like that, the resource is being distributed such that over time, everybody is
Gets
at
equal
an
share.
equilibrium.
Mm.
Because
Correct.
you're not actually distributing resources
equally. At end
You're
of the
just
day,
making sure that you distribute in such a way that at some point in time,
everybody's resource
a
is
very
equal.
poor person is as good as a very rich person.
So you're distributing unequally
So that everybody
so that-
becomes equal at some point.
Yeah.
Which is very counterproductive if you look at it in a very practical sense.
No, yeah, right.
While
Poor
you
people
want,
would give more, right?
the poor to
No,
become rich,
but
but you don't want.
that situation only arises because he is controlling his spending and he is maintaining that state, and that is up to the individual or the you can say.
Yeah, pardon. Yes, Ankit, please come again.
What I'm saying is that is still dependent upon the spending, savings, and earnings that he is getting.
That
And
is fixed.
that
That is fixed. We have not changed that. We have only changed the government's policy.
yeah, we have changed, but
See, the
in
nature of expenditure nature of individuals are not changed. They are not altered. They are
I
fixed.
think what he's trying to say is that supposing let's talk about S. So S starts with 50,
And
reaches 100,
and
reaches
this is
100.
and there is one
So
very
what-
very interesting. There was a minus thing there, and it vanished. There is point minus 0.09. It means that somebody is in debt as well, continuously in debt. His nature is to take loans. Still, the money is getting equally distributed, isn't it? And this is a wonderful thing. Somebody who's continuously taking debt, fine. After some iterations of transactions, what is happening is that he is getting the equal share amount of share.
But that is considering you have zero inflation.
That is considering you have zero.
Inflation. Because
Of course.
because basically
money
we
is
are
not making
equating
Model we are
yesterday's
creating
money
is
to
zero
today's money.
inflation. Yeah, the model we have created is
Zero
based on
inflation.
zero inflation, right? Because if it was inflation, we would just
Keep
this
one constant.
this
One.
value would increase. Yeah.
Also, to make it a little more realistic, what we can do is, so we can create some thresholds saying that if a poor person becomes richer by this threshold, his spending pattern should also change.
We can do it, but first of all, we should discuss the mathematical aspect of it.
Of
Is
course.
what we have done, is to make the sum of fractions equal to 1, the row fractions and the column fractions. And what is that mathematically? What is the mathematical significance of that?
Is it just me or the first iteration is very unintuitive? Someone who had only 50 rupees or someone who had the least amount, 20 rupees. In the
Getting a lot
second
of
iteration has the most amount.
This would be very alarming.
It's like going up and down, right? Kind of. Yeah, it's going up and down.
It's fluctuating.
Yeah.
A lot of
So it's
juggles.
like, yeah, converging, but like in the triangle way, right? The bouncing off of the triangle.
Very
Have you
much
seen-
chaotic situation. Yes.
Have
A
you
lot
seen
of
that?
chaos. A lot of chaos in the beginning.
Yeah. So it's like this.
Maybe the resistance.
So we're starting like this, then we're going low, then we're going high, low, high, low.
The initial resistance to change.
Hey, why don't we plot this?
You want to
Ah,
plot?
this variation we
That
can
would be
plot
really
it.
nice.
We can plot it.
Sorry. My bad.
So, the conclusion we have come at is how to make a equitable distribution of resources. Not equitable distribution of resources. I mean to say that at the end of the day, everybody is having the same amount of resources. Is by ensuring that the sum of the fractions of rows and columns are 1. Fine. This was suggested by Ankit. So what was our problem at hand, by the way?
One second, I'm just making a few changes. Oh, this can't be like this, is it? 7, 8, 9 not high. Okay, it has to be negative. Sorry. Can Can you just repeat? What is the question at hand, right?
What is the mathematical aspect of it? That is what I'm trying to ask. How is this related to some mathematical theory, linear algebra, to be very precise? What is the relation of this problem with linear algebra? Matrices apart. What do we call in terms of linear algebra when the sum of the fractions of rows and columns turns out to be 1? We have seen this as a raw problem.
Hmm.
This is it, yes.
That's called a stochastic matrix.
That's called
Stochastic matrix.
sarcastic matrices.
Stochastic.
Just stochastic matrices.
Just like that stochastic gradient.
That's okay.
I don't know. Okay.
In real life, the government only taxes the profit to the companies. They don't tax on the investment that they make or the money that is inflowing. Only on the profits.
That is
Exactly.
no. Actually, that is considering that you're talking about the absolute. See, indirectly, government taxes everybody.
Yeah.
So while you're buying, say, a chocolate versus a milk, you're paying some amount of indirect taxes to government.
So in that,
So even if the corporate they're charging, say, a yearly corporate tax, which is based on your profit that you make, but government is also indirectly charging the corporate for electricity, for land, various other things.
yeah, because of that thing, because in GST that I have studied that this transitive property of taxing, because of that I was forced to think that we should decrease a certain amount of the money that is flowing from each and everyone.
So that
Uh,
leads to
that leads to not just decreasing the value from this diagonal element, but from each and everyone equally, with the proportion that is flowing or incoming.
No. Think about this. If I am, I mean, in the end, okay. In the end, this tax can be thought of for what? I mean, in the end, it's just about, okay, how much have I paid for tax? How much has the government taken from me? It could
Yeah.
have been through buying goods. It could have been by, in
Call
my
it a
income.
net tax.
Yeah, net tax.
Of
It is.
direct and indirect all combined.
That is individual the thing that you are doing now.
So the
If
thing
you're
is that
purchasing, you're selling
the
that-
more you purchase, the more tax you pay. Fine. And the more you purchase, that means the more amount of money you are having. That means individually you are going to get taxed more, and the more you purchase, you are paying indirect taxes more. This is the regime we are in.
in this thing I have pasted can you look at sheet 3 for a second?
There is a sheet 3.
Yeah, I just shared it. Like in the row 5, you can see that government is taxing 0.02% on the net. So what I did is, this thing. What I did is I equally taxed in the same proportion that the money was flowing from each the entities.
Equal taxation. That is what happens whenever somebody buys a goods. Everybody is going to pay same amount of tax for
all
that
the
good.
indirect taxes are
And
basically
that is indirect tax.
Yeah, I did that to account for the fact that it means the tax is being levied on each portion equally.
Fine,
Means if,
fine.
yeah,
No,
the,
horizontal taxing.
yeah, if I will just paste it again, like for a better understanding, just see this one now. This thing. This is what I did. Like it was our individual initial slabs. K was tax getting asking for this percent of tax from each from the net amount of money that was flowing from each point. Then after taxing 100% of this, we are retaining this thing. That thing I equally distributed in this proportions, and we get this distributions.
So you are saying that
Why would you change the distribution itself?
he is saying that the way we are taxed the way we are taxed, that changes our spending pattern as well over a period of time.
Hmm.
This is what he is suggesting.
Yeah. So, okay, I want to clear the mind space for a minute. We try to model something through a matrix so that we can see how, I mean, I don't know. Again, I think we're going in the loop of one, we can't force a matrix anywhere. Two, we are
Correct.
trying to look at the problem as a matrix and trying to figure out things about the matrix. So obviously, one, we cannot model the entire world. Two, the modeled world, whatever model world you're looking at, it should help us do something about understand something about matrices. So obviously, we can think about this. Do you think you know money that flows around and money that is being taxed or money that's being shared among people is linear? It can't be. How can it be linear if more money gets included every year?
Plus,
Right.
plus what Ankit is suggesting, that is
Mhm.
very much contradictory to what we have here to, what linear algebra we have begun to study, because we have changed the matrix itself. So function cannot, we have yet not learned of a dynamic function.
No.
What we have in our hand
Context
is the
of
variables
changing,
only.
context of the changing. It is only updated was based on the amount of text that K is leaving, because in the individual before the system that we were having distribution of 0.1, 0.7, the upper yellow box, uh, the net sum was maintained at individually. That is, all the columns were summing at to 1. Now we bring in additional row, an additional element K, and he said that I will be taxing you equally on that is 0.02 that is 2% on whatever you do. What I
Okay.
will do force us to update the all complete structure in which the money was flowing.
Okay, let's understand what you said, right? So you said the first column represents how
So
much
is
money
so
has moved out.
are you suggesting FOF or FOG thing?
Yeah, because individually K was not an element of our system, equation system. We were having the sum, that is, all the money was maintained. Nothing was created, nothing was destroyed, nothing.
It's still the same. Actually, if you include K in it, K as a whole system with 5 columns and 5 rows, still
Yeah.
the money is same.
Yeah, but the process in which we are accommodating this K is different.
Yeah, that's what I don't understand, because you say I have 100% money, so I have 100 rupees, right? And with that 100 rupees, I've given 10 to myself. Let's split it, right? So I have 100 rupees.
No,
I'm
what
Sudarshan.
Ankit is suggesting is that the lower highlighted matrix, it will not only change once, it will keep on changing.
No. It will
Yeah.
only keep on changing based on this if K decided to change his tax rate, then amount of money that was throttling will change at all the levels.
No, but at
So
every
you-
point, I want to think of my money as 100%. Why would I think my money as 98%?
Of course.
See, what you're trying to say in the second matrix is saying I have only 98% of my money. But that doesn't make sense. With the money I have, I want to call what I have 100%.
I am having 100%, but of the 100%, I am paying 2% of the
Off,
tax.
yeah. Off
And
the 100.
now
No,
I'm
you
remaining with
said,
90.
yeah. So you said off the 100%. So off this is 100%. Off this, you're paying 2.2%. So this has to come on top, right? It has to be part of the 100% that you are moving around. That is why it is more simpler. I mean, it's more better visualized this way, because in this case, that 0.05% that Sudarshan is playing is part of his 100%. Obviously, I mean, I cannot pay taxes from money I don't have.
Exactly.
I think the problem is coming because each time we are getting confused with percentage and the absolute value.
Exactly.
No.
If
No,
you
no,
take it as a percentage and tax also as a percentage, I don't think so it would create that sort of problem.
No, there is no individual value. No, there is only a percentage thing in the matrices.
Yeah, everything is percentages. Yeah.
Everything is percentage in the matrices. The thing is that matrix is the function, and what we have in our hand, what we can vary is variables.
Yes.
That is x. X is equal to c, for example. What we have in our control is x. And how we levy the taxes, or how we
No,
give the
no.
subsidy.
No. Your x here happens to be this, right? Oh, so you're trying to say you can.
No, variable thing. That what is variable?
Variable is the government taxes and
There
subsidies.
is no. Talking about the matrix multiplication and all. Ax is equal to c. A is the
Okay, in that
function.
sense.
X is the input, and that can vary, of course, isn't it? That's why we do mapping and we get a image of it.
No, but what this is saying is okay. If I vary the input, what is the restriction on the input? Let's say sum is equal to 500, right? Sum is equal to 500. Let's say this should always be 500, right? So now, if I make this equal to this equal to this, this equal to this equal to this. I could have just copy pasted, my bad. Yeah. So now everyone is starting with 100. Okay. I want the sum to always be 500. You're saying I can change inputs like this, is it? Which is each person is starting with a different amount of money, right? 200, 60 and 40.
But it still converge.
That's why I was suggesting now the variable should be the kth column.
What did you mean by that again?
What is the significance of x?
Significance of x is
just
the starting point of how the
it
money
gives us a space, right?
I think of x is the starting point.
No, like yesterday we were discussing
Distribution, actually.
It was leading us to a null space, isn't it?
What does that mean? What is leading to null space? X.
No, yesterday, what we were discussing, that point, that projection thing. There was an input which was leading us to a null space.
Okay. Yeah.
Fine. So every input leads us to some space. We discussed yesterday.
Yes.
So that input is a variable thing.
Yeah, this also happens to be one of those inputs. This also happens to be one of the inputs, because that's what we're doing, right? We're re-inputting the output of the previous. I mean, we are re-inputting the output back in, right? This is also an input. This is also an input. This is also an input. All that. But no matter what the input is, even if I put, okay, simple. If I
Fine,
copy
I
this,
get it. I get it. This
Yeah.
age, I get it. The edge thing, that is a variable thing indeed. Yes. Fine, I agree. That is constantly changing. That is changing every time, and that has been inspired from previous iteration. Fine.
Exactly. Yeah.
H is variable. H is the variable.
H is the way. What is H again?
H is the variable here. It is changing after every iteration. The X thing.
X.
H is
Input.
the X.
What we are doing in each row is
Input.
we are just taking the previous X and transforming it to a new X.
Yeah, it's like apply the function over and over and over and over and over and over and over again. Yeah.
Yesterday, on the yesterday topic, I was having one point to confirm.
No, one thing.
Yeah.
One 30 seconds point. So the what we are seeing is that with the help of this iteration or repetition, we are giving a input. Fine. That is leading us to a desired space. Slowly we are getting shifted to somewhere. Isn't it?
Yeah.
We select such a set of inputs that is transforming us to a desired space. Isn't it?
No, because any input I give which satisfies that the total income of the family or total income of these 5 people is equal to 500,
500.
will still lead to this. So
Even if we change the sum to something different, then the amount, the balance point will just shift, but that will be equal.
true.
Yesterday also the input was only a straight line. No? We had a constant of a straight line. We are also having a constant of 500 today. Input had to be on a straight line. That's not an issue.
No. Input can
is
be,
5?
and that is a different thing, now. That was a special case at.
Of course. The question at hand was I'm talking about a question at not in general.
Yeah.
That becomes a possibility, right?
What I want to do this.
So I'm wondering what we can maneuver.
Wait, how do you say input is along a line? Is it along a line?
Not today. Yesterday I was.
Okay. I was confused. Sorry.
In the copy of sheet 2, I have just changed the sum, but it's still being distributed equally. That was the point that I was saying.
Yeah.
And
The total sum will change.
Yeah, whatever the input is, it will just equally divide it.
Divide it, yeah.
After certain time.
Okay.
That is what I was wondering. What is in our hand? What we do with the matrices? Everything is kind of automated here. The learning we take home, that okay, if we do this to a matrix, this change to a matrix, this property of, if we tweak with this property of matrix this way.
No. I think you're getting a wrong idea. What you have to do is observe what is happening, which is observe that no matter what the starting input is, this matrix is actually taking that input to equally distribute the values to everyone. That is, so sometimes it's not that you have to, the learning is such that, okay, if I do something to the matrix, it's more like observing what this matrix is doing.
The function of the, like, what are individual functions do? Okay,
this function is very unique. That's how I think about it, right? It's a very unique function, which when applied to any sets of input, even if they're random, right? After applying the function multiple times on the input, they will all converge equally among all the users.
So I'm getting a feeling that it's somehow it's forming a Markov chain.
I don't know what Markov chains are.
So Markov chains are basically you have some say you have some three events. So there'll be some probability of an event happening. So
Understood.
each time an event happens, it depends on your current state. Does not depends on what your previous state was,
Uh,
which is also happening over here. No matter where you start, you'll reach at some X point, and that is
Desired
not
point.
dependent on your previous starting
Initial.
point.
Exactly, exactly,
It's
exactly.
your next transition is only dependent on what your current status is.
But
Markov's chain.
here we are means applying the same metrics again and again. But this thing, if there is a loss or there is a net gain, then the converging situation never occurs.
That is altogether a new situation. So what I was suggesting of this matrix, this function to say this function is that the inner matrix is kind of frozen, and we can maneuver with the periphery of this this matrix. That is to say, last column and last row, unless and until the sum of both of them turns out to be 1.
Last row and last column. This
We are maneuvering with this only. We are changing the values of these two rows, these two entities only.
yeah.
Last row and last column, and thereby maintaining the sum of 1. Sum of fractions equal to 1.
Or how I would look at it is, if there's a matrix which has rows summing up to 1 and columns summing up to 1, then whatever input I give,
Fine,
the
exactly.
output will just be, I
Same
mean,
for
it will
everybody.
converge. Yeah, converge at a point where it's equal for everybody. Yeah. Yeah. Okay. Let's not stay at this point for too long. Do you want? I mean, are you guys up for a little bit more of discussion, or?
So the conclusion, mathematical conclusion we come at is that we can apply a function that can lead us to a particular space, desired space to be precise.
Desired space. Is it desired? We don't know. I mean,
No,
for this question, it is desired. Obviously, you want everyone to be equally rich or poor. But yeah, you can call it an equilibrium state. This is more of an equilibrium state than the previous one. I mean, this is actually the same thing as what we did yesterday. Sorry. But we're able to see it more clearly in this case, even with a bigger matrix. We saw this with the 2 by 2 matrix before. Now we're seeing it with a 5 cross 5 matrix.
Yesterday on things were getting saturated after a point of time.
Yesterday, was the sum of the rows also equal to 1?
Yes. No. It was 0.7 plus 0.5. No, it wasn't.
No,
Right.
the was not 1.
Yeah. So when the rows were not, so what is the difference between the previous one and this one?
I forgot an answer to this question.
Let me rewrite the previous matrix. 0.3, 0.7, 0.5. Right, this was the matrix. The input we were taking was, say, 1000 and 0. Right, and what we were doing to this was 0.3 times 1000 plus 0.5 times 0. And let me, sorry,
equal to वहां पर होगा या फिर नीचे बन जाएगा मैट्रिक्स.
Yeah, let me just
that is itself is in sheet 1, if you will see.
Is it?
Yeah.
Okay, my
You
bad.
just have to update this.
Perfect. Okay, so this is 0.3. This is 0.7. This is
0.5.
0.5. So sum of this is
1.
Sum of this is 1, and this is the same as here. Sum of
Oh.
H5, H6, yeah.
0.8, 1.2. 0.8 and 1.2.
Sorry, you just. Perfect. Right? Where is the convergence? The only thing that we see is that where are these 2 points converging? Maybe if you want to even do it. Actually, it's already converged. Sorry.
Already converged at 4th.
Mhm.
Can you make this conclusion that each time the column sum is same, it will always converge?
Okay,
I
let me
guess-
do
I
this.
guess-
Let me. Okay, no.
I guess
let,
so. I guess so.
Let me make a new matrix and 1 minus 1. Sorry, you want column sum of 1, right? So you want
Yeah, column sum of 1 for both.
2
Let's
and
take it
minus.
like 0.6 and 0.4 and
It'll
0.2,
converge.
0.8.
It will converge.
Whereas if we just change it to where the sum is not 1, let's see if it converges.
No. So this is so what you said was if the column sum is
If
equal
sum
to
is
1,
1 for both the columns.
yeah, both the columns, right? This
That
column
guarantees
has 1.
conversion. That guarantees the conversion.
Aditya, is this what?
Yeah,
This
yeah,
is what you said,
exactly,
right?
exactly.
Okay,
Yeah.
okay.
If column wise sum for both is same, equaling to 1, then probably it should converge.
You
Yeah.
can just cut and paste these values itself, na, in previous one, you will see.
Yeah, that's
Like,
better.
Yeah, just
1, 2, 3, 4, 5. No, don't do that. 1, 2, 3, 4. Oh, okay. Has to go somewhere else, is it? 1, 2, 3, 4, 5. So if I do it here, it will come. 1 second. So 1, 2, 3, 4, 5. My bad. Let me do it like this. 1, 2, 3, 4, 5. No, it's not happening, is it? Why is this not changing? Oh, I put
Probably because of the
it try to change certain
dollars. Is it dollars?
static.
Let me
Yeah.
change it to, what is this? This is I10.
I11.
No, it is J10, right?
Hmm.
And this will be I12
11.
and J12. My bad.
Uh,
11.
No, 11.
Oh, my bad. So the previous one should be 10, right?
Yeah, previous one should be 10, which was what you did.
Yeah, I did that. Okay. So
वो converge तो हो गया.
No, we haven't.
no, I haven't.
everything.
I haven't applied it. Let's say they start with equal amounts, right? And I copy this and paste this.
Oops, it's bouncing like anything.
Why not we just increase it a little bit? Let's see if it converges.
No, 100, 500, 100, 500, minus 300, 100. There's no chance of conversion, I guess.
Looks like.
See, it's bouncing.
Hmm.
So how did this happen? Because we took a minus thing there.
I mean, if you want the sum to be 1, you have to have a minus here.
Why not we do it in
Maybe-
fractions first?
and
Fractions. As far as fractions is concerned, I guess that
So
that conversion will take place.
Yeah. Let's try with like 0.2, 0.8 or point-
Exactly.
for that,
0.8.
0.6, 0.4. So it converges.
well,
Like anything.
now here is an idea now, like for this matrix that you have written,
A very important result we got, no? We cannot deal with minus thing, huh?
yeah, for
I guess why the problem was there, probably because we were dealing with minusing, as somebody just said.
No.
no,
The
what
probability could not be negative, na? It
Uppers,
has to vary between 1 and 0.
right.
You can see it like these two column vectors means this matrix is multiplying with x and y.
0.1, 0.9.
Means the initial state. But if we are having that in a fraction and that fraction is 1, what is having is you are just dividing the input that is x equally in that proportions, and similarly y. That is like linear combination, but you are just dividing it in certain proportions and outputting their sum.
Wait. What you're trying to say is,
I'm saying like what we have here, what we are doing is we are multiplying it with x,
Mhm.
means inputting. This matrix is being multiplied with this input.
Yeah.
We have this yellow input to the matrix, this green matrix.
Yep.
Mhm.
And how we can see that is a linear combination of these columns of the green matrix. Now what it is doing is it is taking x from the RAM. Let's make it blue. It is splitting that in the proportion of 0.2 and 0.8. That x is being split in 0.2 and 0.8. Similarly, x is or y is multiplied with 0.3 and 0.7. So that 100 is also splitting in 0.3 and 0.7. And nat what we are having as output is just their sum, the splitted values in the rows. Because what we are writing is
yeah, that's the case for all matrices, right?
Yeah.
Oh, okay. You mean only when they're splitting? Okay. Okay.
I have one curious question. Like, so the minus cases, it's not working fine. But what happens if you just make is equal to 1 in both the column and the rows with help of minus negative also? So like for example, you were using like 2 minus 1, 3 minus 2, something like that, right? But in the same kind of thing, you need what happens if you just equal it to 1 in the row wise also?
Only row wise, huh?
What changes
Okay.
will it be? Yeah.
Both
Point
So both
row and
column and
column.
row wise.
Both
Both
column and
column
row
and row
wise.
wise.
Keep it negative first.
3.7.
No, not 0.7 wise. He's saying we have done that row and column 1 and sheet 2. He's saying that keep it negative.
No, wait.
Make it
Look at this. Look at this first. I think this is very interesting.
Okay, this is really interesting.
So this was I was about to speak.
I was coming to a conclusion. The gun stands skipped.
So now if the rows also, okay.
So
I mean, okay.
just 1 second. I would like to give a physical significance of what we just did. Previous thing. We were giving an input. It was leading to us a space. Fine. And now that input kept on coming closer to the desired space until unless the input is equal to that space and the input coincides. This is what we are doing. Let the input come from anywhere. Ultimately, slowly we are going to get it converged with the desired space or the known space to say.
No, I don't follow. I didn't follow your explanation.
So what we are saying that there is input, variable input that is varying. Input is varying. That is leading to a space. Fine.
Oh.
That input
Okay,
eventually
wait.
coincides.
Wait. This is not happening here. Okay, wait. Is it not a? Oh, okay. Just okay. Sorry. My bad. Wait, here the two values are equal also. This is a bit different from this, right? This here the two values were different.
Okay, this is really interesting.
So basically, when you have row wise sum equal, so
Both
you
of
will
them.
have both the values converging at an equilibrium.
Yeah.
When you have
Yeah, so
column
now you can use negative
sum
value to
equal,
make rows equal,
So what
but
we
not
Maybe,
only two.
maybe,
so,
maybe.
no, we will do it. But just let me give a short, inference. The previous question that we were discussing about taxation system, the that equitable or equal distribution we were getting was because of this row thing. And we were thinking that okay, input and tax and subsidy are equal. That's why it's giving us that thing. No, 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 no. Only if the column sum is changed and row sum is maintained, it will give the equitable distribution. It will be achieved that way itself. We can check it out.
so why
Isn't
don't
it?
we check it
Does
out
it
right now?
really have something?
And if we want to
do
keep
with
the
difference
if
of
we
column
come
sums?
if we want to
Wait,
keep the individual's property constant, we can keep the column sum equal to 1.
Yeah.
Does
No,
this
wait. One second. The equal distribution would have been 100, 100. Why did we didn't see 100, 100, did we?
No.
So how that connection is not the same, right? As Nishan was trying to say, if we just do the row, okay, I took negative values here. Looks like negative values.
That
it's
is not working. Not
Yeah, that
working.
is not
Which
working.
is because the probability couldn't be negative.
Yeah.
We can only spin from
Yeah,
100.
so
There is no point
one
of
thing like, can
there's
you
no negative
change that
percentage.
-1 and the 2?
Also,
Like-
negative of a percentage doesn't make sense.
Wait. Chituraj, can you tell me what you want to do?
Just
Raja.
like -1 and 2, can you change that columns just to see what it reflects?
-1 and 2.
So can you scroll down to maybe, can you see
okay.
where?
We are having the unit
I'll do something like sir did. I will hide.
Truncate the columns.
Yeah. Last two columns. Hide. Yeah. So these are the last two columns. So these
Just
two.
increase the width so that the absolute values could be visible.
Okay. I mean, it's a very, 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 very
No,
big.
e
to the power 80.
That's not possible. And the two values on the last two rows are different. So there we are not reaching anywhere.
Yeah.
Does this have something to do with the unit factors? If we have a matrix that consists that is made up of unit factor.
Wait. Unit vectors means, let's remember what unit vector means.
1, 1,
The
1, 1.
No, magnitude is equal to 1.
One.
Yeah.
Okay. Sorry.
Is the magnitude of
Two.
this equal to 1?
Okay, great.
No, it's not equal to 1.
No, it's not.
0.2 square plus 0.8 square is
0.8 square.
to 1.
Yes. Yes.
not.
Not equal to 1.
No, it's not.
That is why I wanted to, before you,
Divulge into it.
yeah.
And one more thing, I have a question is like, I think the matrix can have negative values. Like for
Yeah.
example, Sir was mentioning
Exactly.
that because negative means it's like a depth kind of thing. So we can have negative, but the converging it's not happening. Maybe
No.
maybe due to the large variation deviations.
So
If we just make a negative value less, then it's
why don't
possible,
we
I think.
simplify this matrix like so was giving some idea of factorization?
What do you mean?
Why don't we?
We were going to discuss factorization only. Correct.
So why don't we factorize this and see if we get some sort of relation?
Which, so do you want to work with this matrix or do you want to work with the matrix that?
That was converging.
So you want 0.2, 0.8 and 0.7, 0.3. Let's not date that. It's very fast.
0.5 was.
Let's do this 0.5, 0.5. Yeah. Something is So yeah, obviously, okay. Something is wrong here, right? We started with 200 rupees, but now both of them have a sum of, let's keep the sum.
$222.
Yeah, obviously, right? I mean,
So Lakshman sum is 1.3 na. Lakshman is
exactly.
printing machine, printing money.
First law of thermodynamics
Yeah.
stands violated.
Lakshman is printing money.
Yeah.
This first law of thermodynamics stands violated, dude. Energy is getting created.
पैसा ही पैसा हुआ.
Great observation, Srivinayak. Great observation. I was just
Yeah,
in the
because I
chat.
realized if the two numbers have to converge, they have to converge in such a way the sum is still 200. They converge to the same
Then-
number, but then I was like, wait, the only number that can be is 100.
Then for that, I think we need to make both the columns and both the rows
Arey,
equal.
we did not observe it for the that sheet 2 thing. Maybe it is also not summing up to the initial amount.
No. Aditya said something very nice. So he said, what if you try to make both the row sum and column sum equal? I actually did that once. Remember, I did 0.5, 0.5, 0.5, 0.5. This is the only way
Right.
this becomes. So maybe do you want to move this to third
Also try
dimension?
like-
Meaning instead of going to 6
You also
dimensions,
try
we'll go
like
to third.
0.4, 0.6, right?
Yeah, 0.4 and 0.6 here, is it?
0.6. Yeah.
And
so
they're
in that
0.4 and they're 0.6.
Yes. Yes.
So 0.4
0.6.
and
No. Point,
Here actually you need to
0.6,
reverse it.
0.6,
Like
0.4.
0.6 and 0.4.
Same result.
Same
Same
result.
result.
See?
Same result.
Yeah.
Hey guys, if
Okay.
somebody is writing down the conclusion, that would be really nice. I don't think that tomorrow.
Now we will write down at the end of the day, not an issue. Okay, let us fix it. We'll be done at 1:15.
No way.
Sure, we will.
It at 1:15, fine.
So
So
if
anyways,
row sum equal to column sum, what is happening in this case?
It will
Okay.
converge at equal points.
Whether it is converging to the average of the inputs or is it converging to the same value, does not calculate the average. Like in this case, 50
And if
and
the
150
column
average
sum
is
is
100.
equal,
Wait.
then it
He's trying to
is
say something. Yeah. Let him finish, maybe.
Chitraj, very important thing.
Yeah.
He is saying that the convergence is at the average of the two inputs.
I mean, you're equally splitting it. Yeah, I mean that's how we were thinking of it in this also, right? Where how did we rename that? Question 7, is it? Okay, I'm confused. Copy
Question
of
we
sheet.
didn't solve. We say on a sixth only.
Oh, here. Sorry. Yeah, sheet 2. So here also we saw that, right? If the row sum is equal to
Maybe
column
that-
sum, it's
you converge
equally.
at equal points.
And that is the sum of
Sum
It's
divided by
average.
number
that is
of people.
average.
Yeah,
or-
average.
That is
Yeah.
average. that is
Yeah.
average.
However you want to see it, you're right. If you have to split it equally, yeah, it has to be average. You're right. Convergence at equal points, or to say, easier to say is convergence at average. Is it average of
Sure.
total starting income? Let's say total starting x comma y. Is that better? So
Hmm.
Yeah,
if x
sure.
comma y is 50 and 150, which is okay. So let's write
200 than the average number.
And the second observation is that if the column sum is 1, then this a new equilibrium is reached, but that is not the
Equal.
equitable. That is not equal. Equilibrium is reached, but that is not equal.
Okay,
No,
okay.
I think there's a convergence, but it's not an equilibrium.
That is not an equilibrium. However, that is not the case when we do it with
Yeah.
there is some redundancy. somewhere when the sum is equal to 1 for the rows.
So you want to do rows again? Sorry. I went
No,
to.
rows तो fail हो गया ना. वो तो
Exactly.
No, we can. That is also an observation. Maybe you can write that later. If column sum is equal to.
we can find the error maybe, someday.
Wait,
And
row
that-
sum is equal to
and-
column sum is equal to 1 is also important. It's
Yeah.
yeah. Column sum is equal to 1. Convert.
Maybe we can someday, find out.
But no equilibrium.
Guaranteed. Right?
But
And
no
we also.
equilibrium.
Yeah, we also saw how to find that x and y. That is through set of finding the point that goes to the null space. Remember? Right? This connects back to, maybe Aditya was not there, but this connects back to finding null space connection. Right? This is clear for whoever was there yesterday, right? Chetan, Maria.
Here I have one question.
Mhm.
Does null space only exist when there are duplicate columns in a matrix?
No, when did we say that? Okay,
No.
null space exists for all matrices. What is the null space of this matrix?
0, 0.
Exactly. So null space exists for all matrices.
Means
Okay. Now reframe your question. Yeah.
For no zero inputs.
Huh.
For no
So
zero inputs, if there is a null space, then that means the matrix has a dependent columns.
yeah.
That I wanted to
Or
clarify.
linear combination of each of them.
Oh, so you want to write it down as a you want to write this out as a observation, is it?
Yeah.
Yeah. Okay. So what did you want to say?
I said that
If null space more than 0, 0.
null space exists for the input other than 0, 0.
Yeah, null space. Exists.
For input other than 0, 0. Other than 0, 0. Then
Yeah.
the matrix has dependent columns.
Okay.
And we have got a new problem statement as well, that if the sum is equal to 1 for the rows, sum of the fractions equal to 1 for the rows, then there is some kind of error. Maybe that error means something. So that error has some physical significance. That is the thing to find out. But there is an error. Money is created or energy is created. Maybe write it down. Law of second law of thermodynamics, maybe.
Where do I write this? This is maybe new sheet itself. How many sheets do we have? God, okay. I'm just clearing this one. What happened to the sheet? What happened?
You just cleared on.
I just put backspace. How did it remove the grid lines?
I was drawing something to discuss, just a short note, and that I changed the properties of that sheet earlier. You just undid that.
Okay. Are we done today, or do you guys have more energy to go? Sorry, Ishana, are you saying something?
I'll take your leave because I'll have to wake up at 5 tomorrow.
Yeah, sure. Nishan, I can't
Okay.
hear what you're saying. I think you're on mute or something.
So I was saying that maybe we can write that equation of function to mint money. Minting money. Apply this function and start minting money. Apply this function on a bunch of people. Whatever is getting minted, extracted. Okay, someday maybe. Okay, I guess this is it. This is 1:15.
So
Can
I
anyone
have only
see
one small
sheet
thing,
7?
like
One thing
if
like for
anyone
question
could,
7, I solved it using this approach. But when I tried the yesterday's approach, it didn't give me an answer like the equation and that approach. In the spreadsheet, I got answer, but not in another way.
Maybe we'll discuss it tomorrow.
Yeah, sure.
Just write it down. We'll discuss it for sure because that is really interesting. And both of those two things must converge. One should confirm the other, isn't it? We'll discuss it tomorrow.
I have one quick query, like what is null space? If you could tell it in 1 or 2 minutes, then
1 minute null space.
Okay, that's a very nice thing. So who's gonna take this question? Oh, please!
Okay,
I've already I've taught it once. It's your turn.
see, Chittu Raja, I'll try, fine. But this definitely does not mean that I am going to tell you everything about null space. But at least you can get a glimpse of what is null space. You will kind of make an imagery of it. So for every input there is output in a function. Fine. Chittu.
Okay.
There is input, there is output. Whatever is the output, we call it space. Fine. If some kind of input is leading you to 0, 0, we call it a null space. If some kind of input is leading you to a straight line, we call it a line space. Do you get it? What is null space we were talking about? The image of a function. There is input, there is output. The image that output makes is the space. That could be a null space. That could be a straight line. And there are various
range or something.
Kind of range. The image. There could be there are many properties of null space. It is a very interesting space. We would be hearing null space repeatedly back and again, but you would rarely hear there is a a plane space or there is a straight line space, but you will repeatedly hear null space. That is to do with the very unique properties of null space. That could be a matter of discussion for another day. But as far as the null space is concerned, I guess I have told you what is a space or null space.
Yeah, that totally.
Yeah,
Okay.
Can you make one more observation?
No. Before good observation. Chittu, I just want to add to what Nishan says. Nishan, when you mentioned line space and plane space, we don't refer them as line spaces or plane spaces.
Yep.
There is another way of, naming them. Let's call okay, my name is Nishan. I mean, my name is Vinay. Sorry, my name is Vinay. You call me Vinay, right? You wouldn't call me something else. So you cannot. So what would you do? So you get a. Okay, what does it mean to be a line space? You've called it line space. What does it mean to be a line space?
That meant that it is along a vector only.
The output is along a vector.
Output is along a vector, along a line. Only and that line is what is the line? What the line is a part of the space. So what do you call it?
Span.
Subspace.
Mm-hmm. Yeah. Who said such subspace?
I.
Very nice. Yeah. So
Sorry, is subspace.
yeah. So it's a subspace,
Chota
right?
space, a chota space.
Yeah, chota space. So subspace. So when you think of a line in a R2,
Fine.
how am I denoting a plane in R2? I'm saying that it's just R2, right? It's a subspace.
R2 plane.
I'm defining it through the subspaces, right?
Fine.
What are the subspaces of R2? It can be an R0, which is a point.
R1 a line.
R1. R1 is a line and R2 is a plane, right?
Plane.
So when I think about subspaces, I will say that I will call it subspace itself. I wouldn't say line space or plane space, right? I think I don't know why it's done or not. That's the way they terminology.
We do not call it a space, rather the subspace.
Yeah, so it's a subspace of the dimension one dimension, right? One-dimensional subspace.
One-dimensional subspace, exactly.
It's a line, right? So I've just defined a line which is passing through 0, 0, 0 as a one-dimensional subspace. So I don't know. I'll tell you why I'm telling this. Cheturaja, when if I have take a matrix 1, 2, 3, 4. What input goes to 0, 0?
What? Okay, if you are asking for output, so you can give input as a 0, 0.
Should be 0, 0 itself, right?
Yeah. Can any other input go to 0, 0?
No.
No. Yeah.
Right? It is not possible for any other input to go to 0, 0. Only 0, 0 gets mapped to 0, 0. Right? Now, 0, 0 is a subspace of, so our input is in R2. Right? 0, 0 is a point in R2, which is a subspace by itself. Why do I say that it's a subspace by itself?
Because every input is getting mapped to it.
Sorry, can you repeat that, Chetan?
Every input is getting mapped to 0, 0. Right?
Exactly. So, Chituraja, I'm hoping you've not. Is there any other way I can call you? Like, is it easier to call you?
You can call me any name, like Chittu or Raja, anything is fine.
Yeah, Raja sounds, great. So Raja is
Brilliant.
yeah. So what I'm trying to say is, do you know what a subspace is?
It's like in a space, maybe as you just now mentioned, right? If it is a 2D space, then a 1D, everything would be like point, line, plane, everything would be the subspaces for it.
The definition of subspace is a little bit more complicated than that. So if I take this line, which is, say, x is equal to 2. This is a line in R2, but is it a subspace in R2?
Yes, I hope so. I'm not sure.
Yeah. So you think that this might be a subspace in R2, but in reality, this is not a subspace of R2. Let's start from beginning. Like, let's start on the starting. If I take a point, right?
Yeah.
If the point is 1, 2, okay. What can the linear combination of 1, 2 reach?
Only 1, 2, because that is the point, right?
Okay. What is linear combination?
Okay.
You're allowed to do what? You're allowed to do two things. You can scale
Add it.
and add. So what if I give a single point and I ask you, you can take the linear combination of it. That is nothing but saying, let's do this. Very, very simple. 1, 2 plus 1, 2 is a linear combination. Yes or no? I am just taking the vector, right? I'm taking the vector. Okay, when I think of a point in R2, I always think about it as a vector. A vector starts from 0, 0. In mathematics, we think of a vector that starts the origin, the tail is always at 0, 0, and the head is at where, 1, 2. So this is a linear combination, right? 1, 2 plus 1, 2 is a linear combination, right? Raja, do you agree that 1, 2 plus 1, 2 is a linear combination?
Yes.
Right? Because I'm just adding the two vectors. And what am I adding? I'm adding the same vector twice, which is nothing but saying 2 times the vector, right? This is equal to 2 times the vector, right? 2 times 1, 2. Or what I could do, I could scale 1, 2 by 3. 3 times 1, 2. I can scale it by half. Half times 1, 2. Now, if I think of 1, 2 as a subspace, that's what you thought, right? You thought a line completely was a subspace. I took any line. This is any line, right? This is some random line, right? Now what I'm doing is just saying I'm taking a random point, 1, 2. And I'm asking you the question, is it a subspace? What defines whether if it is a subspace or not depends on this. If I take any linear combination of that point, which is nothing but if I scale it or add it, whatever points are inside that subspace, if I scale it and add it, I should still land inside the subspace. What happens when I do 1, 2 plus 1, 2?
Will be 2, 4.
You'll go to 2, 4, right? Is 2, 4 in the subspace of 1, 2? We thought this was a subspace by itself. We thought 1, 2 was a subspace by itself, right?
Yes.
Right? But 2, 4 is not inside the subspace of 1, 2.
Yeah.
So this cannot be termed as a subspace.
Okay.
So if I take another point, 3, 4, can it be a subspace?
No.
No. What is the only point that can be a subspace?
0, 0.
0, 0. Why?
Because
how much ever I
0, 0 is added to in 0, 0, then it remains same. It cannot be
Exactly.
scaled.
How
It cannot
much
be
ever I scale, how much ever I add 0, 0 to itself, I will still be inside the subspace. And the subspace that I defined was 0, 0.
Yeah.
So this is what defines a subspace. So can you extend this for a vector
line?
3? If I take a vector 3, 4.
Okay.
What is the subspace that it can reach?
As per my understanding, vector is just a direction. So I think that can be extended until infinity.
Yeah. So I can say alpha times 3, 4. When you say extended, it's nothing but scaling it, right?
Yes.
And I can add to a different scaled version of itself, right? So what points can this reach?
That is like the same line, it can go up to infinity. Like
Exactly. So 2, 3, 4. So let's say this is the point, right? When I'm scaling it, I'm nothing but doing this, right? And when I scale it negatively, what happens? It goes like this. right? So I'm able to reach what? What all points?
What the infinity is like.
No, think about it in the Cartesian plane. I'm able to reach 3, 4. I'm also able to reach 6, 8.
6,
I'm also able to reach minus 3,
minus
4.
3. Minus 3,
Do
minus
these
4, right?
points have something in common?
The multiples of the same.
3, 4.
Right? It's a multiple of 3,
Yes.
4. So what is this? What is this? What is this
Linear
structure?
two, are you saying?
Line, right? This is a line,
It's a
right?
line. Yeah.
And what are the properties of this line?
Subspace.
Does it include another subspace that we talked about before this?
Yeah, null subspace, it will be including it.
It includes the null space subspace that we saw before it. So this has a possibility of being a bigger null space, sorry, bigger subspace than this. So this was the minimum most subspace. And the next subspace that we can reach is a line, right? Because a linear combination allows you to scale that vector how much ever you want. So you can reach any point on this line, right? So if I take all possible points on this line, right? If I take 3, 4, I take 0, 0, I take 4, 6, 8, all these points, and I take a linear combination of them, I will still lie on this line. So line is a subspace of R2, and it is a one-dimensional subspace. I don't know the term is perfect. Let's maybe for now let me skip that. You know that a line is, line is only going through one dimension, but let's keep that in bay. It's fine. Maybe I'll confirm that once, and maybe I'll come back to that. But you see that line is a subspace of R2, and this subspace, the definition of a subspace is very, very. It should be very clear to you. You should not have any gaps in that understanding. That's why I wanted to go to subspaces. I'm sorry if you all wanted to leave and maybe I'm holding back.
For me, it's fine, but others not like, like.
Yeah. They can leave anytime you want. Yeah. Understood.
So
Sorry.
there, I think like x equal to 4, it was not as subspace because we cannot add it. If we add it, it will be changing. I don't know like how it would be happening. So if it is a vector,
Okay.
then it will be a scaling or addition. It will be in the same line. But for x equal to 4,
Yes, let's do that. So let's take a point on this vector. If I take this point on this vector, I can represent. So x is equal to 4 means this is nothing but saying 4 comma, wait, x is equal to 4 has to be a vertical line. So this is y is equal to 4, right?
This is y is equal to 4.
Yeah. So let's say I move 3 units, right? 3 comma 4. Now I have a point 3 comma 4 which is on this line. What if I take a linear combination of 3 comma 4? What if I add it to itself? It'll go to
6, 8.
6 comma 4. Sorry, 6 comma 8. My bad.
Right.
And yeah, we never write points like this. We always write it as a vector, and vectors are written like this, right? So this is 3, 4, and this is
6, 8.
6, 8. My handwriting is getting worse and worse by the second. I'm sleepy. Is 6, 8 on this line, which we thought could be a subspace?
No.
Right? So
This is a very good example.
What is
the line is not a subspace?
Yeah. So this particular line is not a subspace, right?
Exactly.
If 0, 0 is a subspace by itself, a subspace bigger than that should include
Zero,
0, 0,
zero.
right? It has to include 0, 0, right? Think about it. If I take any vector and I scale it by 0, where will I land?
Same zero.
You will land at the origin, right?
Yes.
So for any line to be a subspace, 0, 0 has to pass through 0, 0. And every line that passes through 0, 0 is actually a subspace. What did I say?
Means like all the
For
vectors are subspaces.
exactly for a line to be a
Not-
subspace.
Not all vectors are subspaces. Sorry.
All
You
vectors
just
passing
saw
through the origin are subspaces.
No.
Means
Vectors are
it will
defined.
pass through origin.
Yes, vectors are defined in mathematics
exact.
with the tail being at 0. So if you talk about the span of a vector, you don't say a vector is a subspace, you say the span of a vector. Because when you say
Right.
span of a vector, oh, that's what you wanted to, okay, understood. Span of a vector, right? 3, 4. The span of a vector is a line.
Exactly.
If you want to know what span is, it is every point that I can reach by taking a linear combination of whatever is inside this. And we know that linear combination of 3, 4, we've done it. We did it many times over here, right? It is nothing but scaling 3, 4 or adding it to itself, right?
Yeah.
Now, for a line to be a subspace, 0, 0 has to be, it has to pass through 0, 0. Okay? And every line passing through 0, 0 oh my god, my handwriting is very bad. Okay, is definitely a subspace.
Okay. So that means like y equal to mx without constant.
Exactly. Y-intercept should be 0.
Or in other words, you can say span of any vector is a subspace.
Fair enough.
Just a fancy way of saying the same thing
Exactly.
in different way.
It might be a fancy way, but you guys have learned this concept. That's why you're able to use it.
I have seen people just memorize this jargon statements. Okay.
Can you tell me all possible subspaces of R3? This is R3, right?
Yeah.
What
The
are the
first one
possible
is
subspaces?
origin first one.
Awesome.
Right.
So he said 0, 0 is subspace.
0, 0, 0. So since it is.
Oh yeah, 0, 0, 0. My bad. 0, 0, 0.
Yeah, and R.
Line passes through origin, but I don't know the equation for it.
No, that is right. We can simply write R, right? Or no? Shivana?
What is R?
Not
R
all
is the
the
complete line, complete space called line. Also referred as line.
Not all
But
line
can we
passes.
argue on that grounds?
No. A line has to pass through origin.
No, see what
We can say vector.
if we say any line, then we don't imbibe about it passing through origin, as in 0, 0 being included. While when we say R1 or R itself, it is
real line.
understood that it is a no.
And includes 0.
It is not actually that would be my argument, but it would be like we know that R itself is a space, right? R1, R2, R3, all these are spaces by themselves. They are defined in such a way. So instead of a line,
One second. Let me just come let me just draw a box here. This is the typical R2, right?
Yep.
Yeah,
R-
a plane, a plane.
But this R2 is not special, right? I could take other planes like this that is passing
That
through
will be
origin.
R2 as well.
Do you understand what I'm trying to say here?
Okay,
This
so
is
you are saying
also-
that every single plane could be referred as R2.
Right.
Referred as R2, I'm not sure if that can happen. Maybe even I have to
I mean,
look up
No,
that.
I'm understanding your point right now. You are saying that this R2 that you have written and the above box, they both are planes. There is no differentiating factor as such. That is what you want to convey, right?
Yeah. So what I want to say is when we say R2,
Yeah.
we usually look at the XY coordinate, right?
Okay,
I mean,
okay, yeah.
that is what we connect it to. So for now, I don't want to confuse ourselves with these concepts. I just want to think of.
Yeah.
So that's the thing. If we think of R2, then if I say R2 is a subspace, people will think only the XY plane is a subspace. I don't want that to happen right now. Actually, the subspace is, I want Raja to answer. What is the subspaces again?
for R3. Yeah.
Yeah,
Will-
Yeah,
it
yeah.
has to
So you
pass
started
through
with 0,
line
0,
and
0,
yeah.
correct?
And then line passes through origin.
Right.
Awesome.
then
And how
plane
many such
passes
lines
through
are there?
origin.
How many?
There is no count actually.
Infinitely
Since,
many lines.
Infinitely many.
yeah,
Awesome, awesome, awesome.
yeah.
Okay.
So-
So,
And after this,
so I can write all lines passing through 0, 0, 0. And what is the next one?
All planes passing through
The span of vectors, can we include that or it comes under?
it's the line itself. That's the
Same
fancy
thing,
word.
same thing,
Same
same
thing.
What he said right just now.
One more thing you're missing out. Think
Yeah,
about it.
planes, right? Planes passing through.
The origin.
Exactly.
So if your plane is passing through the origin, that itself is also a subspace.
And how many such
So
planes are there?
Again,
that is also
same answer.
actually infinite.
Exactly. So all planes. Through 0, 0, 0. I'm getting lazier by the second. Wow. Okay.
Okay, our next target is 145.
So you had set a target?
115.
No, no.
Yeah.
Yeah, earlier the target was 150. Our new target is 145.
I told him.
Yes.
Yeah,
It
yeah.
won't happen.
So subspaces are done, but we didn't answer the main question. What is a null space?
Null space is
Yeah.
nothing but the minimum 0, 0, 0 origin space, right? Since
So
the
remember this, when you use the term
output-
space, what could be the form of that space? I mean, I'm trying to see if you're able to connect. When I use the word space, when I say null space, what could be the form of the null space? Could it be a circle?
no, it is nothing. Can be
Could it be?
does not carry any space. It does not have
Could
any
it be
region.
this? Wait. Okay, wait. Let's try this again. Now, if you
Even I want to give a try. I mean, I'm not completely remembering, but I want to give a try.
We
Sure, sure.
missed
Maybe-
the target of 145.
no, if you answer it, maybe okay. Why don't you do this? Direct message me the answer. I'll tell you if you're right or
Okay.
wrong. I
Sure,
want
sure.
him to. I want him to take it step by step.
Yeah,
Okay.
exactly. Yeah, right.
Sure. Okay. Raja, can you give me an x and y which goes to 0, 0 other than 0, 0?
If you can
I don't
answer
think
this,
so.
you know the answer to what the question was.
I don't think any other values would make output 0, 0, other than 0, 0.
I am telling there is a value. Now try to find it. We'll think about why there is such a value later. I don't think I can explain that also.
We are entering a greater realm of discussion. A new lot of pattern could be seen in these equations.
Ashik, have you messaged me? I haven't gotten. Okay.
I mean, you asked that what we see when we say about null space, right? So would this be sufficient, or is this? I mean, is this going to the right direction? Or
Yeah, I think it's in the right direction.
Hmm.
But again, we talked about how we cannot. Okay.
What happens actually, like y equal to x or x equal to y, something like that? I think that.
No. Okay, how is it? What is another way of looking at this matrix? Do you know the column view? I just want to ask.
Okay, so x into 1 by 2 as a column vector, and plus y into 2 by 4.
And I want some input for which this goes to 0, 0. You take any way to solve it, but I assure you there is at least one value for which, other than 0, 0, there is some one value for which this goes to 0, 0. Okay. Maybe even mute me. I'm gonna talk to Ashik for a while. Actually, can you mute me for a while, Raja? Can you mute me for a while? Like maybe Raja, can you like not listen to what I'm saying for a while?
Yeah, okay.
I'll talk to Ashik and then I'll come back to you. Okay.
Ping me, then I will just
On chat. I'll ping you on chat. So Ashik said, Ashik, can you say what you've sent to
okay,
me?
sure. Yeah, so I'm saying that a null space could be imagined as a dimension itself. Shivin, I asked that what comes to our mind when we say a null
Right.
space, right?
Right.
So I was, I mean, we do know that our whole space gets diminished to a lower dimension, and that is the null space actually. But could this be a greater view as well, that a null space is a dimension in itself? So I mean, if you are getting my point.
Not really a dimension, but yeah, you're close. Yeah, close.
I have the same thought in my mind.
Yeah.
X is
I mean,
equal to -1.
we know something about null space, that it is like a black hole.
Right.
Just to correlate on a
Chittaraja,
smaller
you're right.
scale, it goes to somewhat like a black hole, or
So
thing
see,
that diminishes
what
or higher dimensions.
Shrivane did was he asked the question to Chittaraja. This question, the answer to this question is actually the answer to the null space itself. Nothing about it.
We are discussing null space. I mean, what was the bigger question here? It was about null space, right?
Yeah. What is the null space? What is the null space? I'm saying the answer to this particular question is the answer to null space itself. What is a null space?
So these
That's
equations
why
seen on
Shrivane
the
asked
page.
this question to Chittaraja.
Okay. Right.
You thought about it as a dimension.
Yeah, I was thinking on that way.
You can use a term that we've
Yeah.
been learning. We've learned till now. You can use a term.
Should I say it?
Exactly different. Yeah, say it.
Span?
No.
Not really.
So null space is a part
Space.
of a space.
part of a
Now you're close.
subspace.
Subspace.
And we
Right,
know what
Yeah.
subspaces are, right? We know what subspaces
Yeah.
are. So it
yeah,
has
yeah,
to be
yeah.
one of this.
True. That is why I was going on that direction, I guess.
Yeah,
I mean,
yeah.
I
mean,
didn't
you saw
really
this.
think of this
Yeah.
way, but yeah, I got
You
it
were
now.
looking at this dimension also, right? Here also you're looking at R2. Instead,
Yes,
if you
yes,
look at it
yes.
as a subspace, it is better. Okay. So I'll get
Right.
back to.
So
Or in
always,
other
I mean, always going back to the subspace thing would be better
Nishan, it's the
instead of
same thing.
generalizing.
Minus
Thank you.
2 comma 1 is the same thing. You're scaling that vector minus 1 comma 1 by 2.
I
That's
was
it.
telling
Same.
that too. I was telling to Chittu Raja.
Right. Okay, sorry.
Yeah.
My
Okay.
bad.
Can you ask him to come back
Yeah.
the conversation?
Guys, I still means I will need to another analogy for that tax example. If someone finds something, please do share
Okay,
tomorrow.
we'll do one thing. We'll take that problem again tomorrow. We'll start from the basic itself. We'll
Yeah.
discuss it from the basic, from the
Yeah.
first principles. We'll forget everything that we don't know anything about that problem. We'll start it just like we did yesterday for the sixth question. We'll do that for that, right?
Yeah.
That would
Yeah,
work.
from another analogy, I was just thoughting like if it would have been an engine, we are we are filling 1 liter of petrol that is converting to mechanical energy. Though, if we consider this efficiency, that lack of efficiency, then that itself we can treat that itself as a tax also.
Okay, we will think of some suitable analogy. I guess your brain
That's a very
goes
nice
so.
analogy. Wow. No, but that was a very nice analogy, actually. That's a very
Yeah.
nice analogy. Yeah, but okay, that's a nice analogy to reframe the question.
Right.
You're right. Okay, we'll think about it tomorrow. What about
I'll add one thing to that, Ankit.
Yeah.
I'll tell you that there are two kinds of efficiency in mechanical engineering.
Yeah, I know.
First law efficiency and second law efficiency.
Yeah. But
So
if you know that entropy, then there is in the quantum physics, there is saying that this having a zero entropy state is not the end. The subsystems goes on becoming
dark energy, you are going to dark energy.
Yeah.
You are going to dark energy.
So-
Okay. Okay.
Raja, are you there?
Yeah, I'm here.
Okay, so you found what values of x and y did you give me?
Minus 1 comma 1 by 2.
Okay, so you've given me, let me write that down. Let me write it here. Okay, let me erase these two. You've given me -1 and 1 by 2.
Yes.
Is this the only point?
No. So apart from that also, I think Ishan listed some value on multiples of this.
Exactly.
True.
What does it mean to take a multiple of a vector?
It means it's scaling of vector.
And what does it mean to scale a vector? What does it mean to -1
Span of a vector you are asking.
Exactly. So what I'm saying is, you said if I input this -1/2, right? If I input this to the matrix that is given right now, which is 1, 2, 2, 4, I'm getting 0, 0. Then you said, if I scale this vector, right? Any point on this line is being mapped to
0, 0.
But whether the positive values will result in 0, 0.
Maybe wait, maybe I'm drawing the image wrong. I'm not drawing it properly. Minus 1, sorry, minus 1, comma.
Minus 2, it will be around like tilted towards y-axis.
Yeah, so 1, 1/2, I guess. Like
Take a mirror image of it.
-1.5. This means third, that's second and fourth.
My bad. It'll come like this. You're right. I am so sorry.
Oh, okay. Yeah. Okay.
Just a mirror image of x-axis.
Now it will come because this side the minus would be there. Yeah.
My bad. Sorry. So if I take any point on this,
Yes.
right, it is being mapped to
0,
0, 0.
right? It's being mapped to 0, 0. Do you see that? This is a subspace. So null space has to either be for R2. What all can the null space be? Null space can be the point 0, 0, which is a subspace, right? It could be a line passing through 0, 0, or it could be a
Passing through 0, 0.
entire plane,
Yeah.
because in R2, can you give me an example of
One
this?
plane. Only one plane would be there. So XY plane.
Can you give
So
me an
what are
example
plane?
where all the points, any input xy I take, if I multiply with this matrix, I am reaching 0, 0. Can you give me an example?
So you want example for matrix?
Yes, I want the example for the function which is mapping all inputs on the plane. That is what this means, right? If the null space is a plane in R2, every point on that R2 plane has to be mapped to 0, 0. So what is that function which maps every point to 0, 0?
Don't overthink about it. Whatever comes to your mind first, that's the
0,
answer.
all 0.
Right.
0, 0, 0, 0. That is fine. That is for sure. Apart from that, I don't know.
No, there can't be an
That-
apart from that.
Yeah, that is the only one.
So what?
This
Can you-
function,
I was doing something else. I didn't focus, but making matrix itself a 0, 0 to get 0, 0.
no, I'm not making the matrix. I asked him a question. Which matrix?
Okay.
If I input all the points on this plane, will go to 0, 0. So I wanted him to give me this, and he gave me 0, 0, 0, 0. So this is a particular function, right? We took a matrix as a function, which takes every point on the xy plane and maps it to 0, 0.
It is regarding one fact that if they are dependent vectors, that is, you have dependent columns, then still you can get 0, 0 for certain x and y.
Yeah, I haven't. Chitturaja, do you know what dependence means? I didn't want to touch that today. Maybe tomorrow.
First, let's check. So, Chitturaja, did you understand what null space is? It's a
It is like,
subspace.
Null space is the beginning of the Big Bang. Without it, nothing is possible.
No, okay. Maybe Raja wasn't here, right? When we discussed the importance of a null space. Null space is very, very important for once you understand the null space, you understand a lot of things about the function, which is the matrix. If you're able to understand its null space, you understand so many things about the matrix. It's like saying if you know the determinant of the matrix, you know a lot of facts about the matrix. It's very similar to that. So can you give me an example of a matrix that only takes 0, 0 to 0, 0, meaning the null space of that matrix? Now you have to give me a matrix which, sorry, sorry. You have to give me a matrix such that
We're just asking how much hours are you guys sleeping?
Okay, I didn't sleep last night.
Oh God, okay.
Rest of the guys,
I could, what is coming to my mind repeatedly is a couplet of Ghalib. I'll tell you after we are finished.
Irshad.
Raja, can you tell me such a matrix?
What is actually the previously discussed 0, 0, 0, 0, 0.
So this is telling that the null space is a plane, is the entire R2. Here, I want null space to be only 0, 0. Maybe we can start breakout rooms after this. You guys are starting to while away your time.
No,
You
no,
guys
no.
should start. You guys should start discussing.
I'm getting, such, midnight ideas. My goodness, Ghalib new vectors. Oh, sorry, linear algebra.
Literally, even when I'm trying to sleep, I'm like, okay, what happens if this happens? What is this? What is that?
No,
I'm thinking about.
I just related one of the couplet of, I guess it was Ghalib's only, and that relates to this, that confirms to this linear algebra thing. I'll explain it after you are done.
Sure.
Actually, I'm not sure like how it is like. I'm not able to think what would be that.
Okay.
Actually, it's like
Okay.
0, 0 in the sense it's an point you are mentioning.
Sorry, sorry. Can you be a little louder? I couldn't hear you.
Actually, I'm not able to guess how it would be. So that
okay.
previous
Why
one
don't
I was
why don't
fine, but
you
now
just draw him two lines that are opposite in directions with the same magnitude? That is easy to see. Like
Okay, yeah.
just draw two lines that are equal, opposite in direction.
Wait. Maybe I'll start him from here. Okay. What does this column view give you? What does this column view tell you?
column view tells like how much in the x direction the transformation will happen. Like maybe it may scale or it may shear or something.
What is
Scale-
it?
X
What
is-
is it scaling? What is it scaling? X is scaling what?
Actually, the 1/2 is scaling x.
X
Is
Sorry,
this
not 1/2, 1, 2.
yeah. Is this changing or is this changing?
X will be the input, so it will change according
Yeah.
to the vector.
So this is nothing but looking at. Is this correct or not? Is this analogy okay or not? I can write it as alpha times 1, 2. Or, okay, simple.
1, 1 to alpha would be more appropriate. Because one vector is deriving the input.
Okay, no, this is also better. X to X, right? This is a better way to
Yeah.
look at it, right? If you want to. I mean, I would preferably look at it this way. I'll tell you why later. But if you think this is easy for you to, okay, now give me a few input values for X alone.
Okay, so the output has to be what?
I
Output
don't
value has to be zero.
care about the output. I mean, I am not looking at the entire, I'm not looking at the right hand side. I'm only looking at this now, right now.
Okay. For X,
If I
we
give
can
some
start.
inputs, yeah, X is equal
Yeah,
to, give me a value. Okay, 0. 0 makes it 0, 0. Okay. Can you give me another value for X?
1.
Okay, that'll give you back your
1,
1, 2.
Original.
Okay.
Yeah.
What is this actually? What is this? What is this 1, 2? What is this if I think about it visually? Visually, what do I
Visually,
think
if I am just thinking about it, 1 makes the input as it is, and the 2 makes it scalable. Like, so 1 is kind of.
No, we must,
Once again, I
start
think I am
from the
just
basics.
confusing. I'm just interchanging
No,
the elements.
not interchanging. Yeah, we must start from the basic for him.
No, let's not go there. Maybe, see, okay.
Because he will get this more confused with the passing time,
okay.
given the situation.
You're right. Yeah,
I think like 2 is for scaling.
No,
1
no,
is
go-
for
don't go there. Don't go
He
there.
is confusing with today what we have discussed, since
Right.
9 p.m. He is getting confused with that.
Okay, simple. What mathematical concept is shown in these type of brackets? I think I already told you before, right? If I say 2, 3, what is this particular representation of 2, 3 mean? Let me go back. Wait. Let me try it another way. What does this representation of 2, 3 mean? What does this
so
representation
that means it
mean?
is 2, 3 is not included.
This is a point, right? This is the represent. How do you represent a point in R2?
Okay. So I was telling about the different ranges. Okay, yeah.
Right. And how do you find where the point is?
That is from origin, like X direction 2 and Y direction 3.
Exactly. Where did you start from?
Origin 0.
Yes, and you went 2 steps. Let's say 1, 2 steps here, and you went 1, 2, 3 steps here, which is nothing but going here, right? You went. Okay, no. When I say this representation, 2, 3 in single brackets, it means a point. So this is how you represent it. This is 2, 3.
Yes.
Now, what is this representation?
It is vector.
Vector.
That is the direction for the point from origin.
Is there some connection between these two? Is there something different between these two? What is the difference between these two? This is saying move 2 in X direction, move 3 in Y direction. This is saying move 2 in X direction, move 3 in Y direction. Just that you are representing it in a different way. I am moving 2 and then I'm moving 3. After finding that, I mean, okay, let's think about it. I move 2 and then I move 3.
Yes.
This is that vector, right?
Yes.
Right?
So,
how do I show this? How do I show this? If you think of taking xy here, right? I am going 2 units in x and 3 units in y. Here I will think of it as 2 units in I cap and 3 units in
J cap, unique vector.
Exactly. So this is nothing but 2, 3. Right? Now, if I'm taking 1, 2, which is nothing but, what is this representation?
It is a
This is
vector.
a vector, right? And when I take a vector and scale it, what happens?
The input
When I take a
value,
vector and scale it, what is happening?
like,
Yeah.
will, like based on the scale ratio, it will increase. Like for example, 2, 4 means it will add up on another 2, 4. In the x direction, another 2, y direction, another 4.
No, I'm
So
just putting x, right? I'm just
yes.
giving a value for x. I'm not changing these. I'm just changing
so
x.
like
Yeah. Oh, okay. You mean 2, 4 as when x is equal to 2, right?
yes.
Okay. Sorry. Yeah, go ahead. So if I put 2, 3, 4, 5, 6, I can go any side in the positive, I mean, in one direction. If I do -2, -3, -4 all the way to infinity, minus infinity, I'll go in the other direction. And in the end, I will be able to go on that line
Infinity.
completely, right? I can go to any point on that line.
Yes.
Right? Now, this part is taking the vector 1, 2 and scaling it.
Okay.
Right? And this can reach an entire line.
Yes.
Right? Now look at this vector.
Okay.
I'll be
What
back in
does
a minute.
Sure. What does y of x mean? Y of this vector mean? I can
Scale
scale.
that y value.
Yeah, you can change the value of y, which will do nothing but scale this, right? It will
Scaling.
scale this,
Yeah.
right? Yeah. So if let me actually write another grid. 1, 2. So my first vector is this 1, 2. Okay. Sorry. Okay, let's I'll label this side so you know where it is. I don't want to write it there. And the second vector is, where is the second vector?
2, 4.
2, 4.
Which is if I scale the first vector 1, 2 by 2, where will I reach?
The same vector.
If I scale the vector 2, 4, can I reach anywhere outside this line?
No.
So when I'm scaling this, I'm getting a line. When I'm scaling this, I'm getting a line. But both those lines are the same. Because 2, 4 is nothing but 2 times 1, 4, 1, 2. Oh my god, that was such a bad mistake. 2, 4 is nothing but 2 times 1, 2. And this is what it calls, this is what is called
Dependence.
dependence of a matrix. What did we do? We saw a matrix. We know a matrix can be written as a column picture. When we look at the matrix as a column picture, it is doing nothing else other than a linear combination. It is scaling the first vector and adding it to the scaled version of the second vector.
Yes.
Now, since we know these two are the vectors, if these two vectors happen to lie, so what is happening actually? What is the Okay, maybe should I go there? Should I not go there? Good question to myself. So what is the span of this?
So infinity, like in that line, infinity.
Exactly. It can
The
span.
line passing through 1, 2, 0, 0.
Exactly. See, when you think about a space or subspace or span, the span can only be a subspace. And what is the property of a subspace? 0, 0. The origin is always included. And subspaces can either be a point, which is 0, 0, or a line passing through 0, 0, or planes passing through 0, 0. Right? We saw that. Right? So this has a subspace of a line passing through what and what? 0, 0 and
1, 2.
do you see that?
And also the other vector. Okay, so you are
That's just a
connecting these
scaled up version of this that lies on this line that passes through 0, 0 and 1, 2.
Yes.
So hence we call these dependent
So
vectors.
this is the span of maybe what is this? This line that was passing through 0, 0 and 1, 2. That's where I got the 1, 2 from. This is the span of the first column. Right? If the second vector happens to lie in the span, so second column lies
In the
in the
span of
span. What is the span? What is the span? Remember, this is the span. So
line passing through 0, 0 and 1.
for this vector, this is the span. And if the second column lies in the span of the first column, then they are dependent.
Right.
So you understood this until now, right? I hope you understood what we have talked about.
For dependent matrix, the determinants will be 0.
Yeah, I don't know determinants is yet, but okay. Right?
Yeah,
Now,
if you want to say it in terms of determinants, the determinant of a dependent matrix would be 0.
Now,
0, yeah.
what does it? Okay, now what happens? My span is restricted to this line.
Right.
Right? Oh my God, it's so tempting to introduce a new topic here. No, it's a topic that both you and Nishan and other people who are here don't know, which is a very, very wonderful topic, but I will restrict myself not to go into that, but it's okay. Now,
no, you can at least take the name of that topic.
Nishan, what happened to your target?
The topic is still null space. Don't worry.
215 target, isn't it? 115 target, isn't it?
We still have those space remaining from yesterday.
Maybe next stoppage, next milestone would be 245.
Guys, it's weekend, man. Come on, we should
Oh, yeah.
extend our target to 4.
Yeah,
No. Either it will be 415 or 445. Choose
Sure,
from
sure.
one.
Okay. Is everyone still? Who all are still here? Anamika is still here. Ashish. Sharma, Chituraja, Ankit, Ashik. Nice. Nice to see a lot of people still here. Direct message. What? 218. Hey, please do. Oh, okay. I cannot talk about it. Sorry. It's a very. It's something that you guys will realize in time. No, the thing is, if I tell it to you, it's easy for me to tell you. But I want you guys to build the intuition from scratch. And if I want you to build the intuition from scratch, it will require questioning and discussions and yeah. So that will
We'll take the slow path.
First
Bring
principle
we'll
it
take the
approach.
slow path is always better. Trust me.
Mhm.
Okay. Now, Raja, given that this is a dependent matrix,
Yeah.
what values of xy go to 0?
You know the answer to this.
We did this.
So
Yeah.
-1, 1/2, and also -2.
No, I want you to tell me the answer now. I don't want you to take steps. I want you to tell me the answer. What is the
Okay.
null space of
The
this
line,
matrix?
actually the points present in that line.
Exactly. Any point present in the line passing through what and what?
0, 0 and 1, 2, 2, 4.
1, 2?
So not that. Actually,
X,
0,
Y,
0 and -1, 1/2.
Awesome.
And then
So,
-2,
line passing through -2 and 1, right? Sorry.
Yeah.
I should always represent lines as points. So line passing through 0, 0 and -2, 1. Awesome. Right? Now you understood that if there are dependent columns, null space is more than a point. The null space happens to be a line, right? So let's get back to this question. What does it mean when only 0, 0 is being mapped to 0, 0? What does it say about this column vector and this column vector? Let's call it
should
U.
not be dependent.
Exactly, which is nothing but saying they should be independent.
Independent.
Basically, not dependent is independent. Yeah. So,
Okay.
can you give me such? No, that's what I was trying to, ask you. When give me a matrix that only takes 0, 0 to 0, 0. So can you give me an example now? Should be very easy.
Yeah. So 1, 2, 3, 4. So
Exactly.
yes,
Most of the matrices we see
very independent.
will be independent because the probability the probability that the second vector lies in the span of the first vector is only a line compared to any point on that plane. I don't know how I got probability inside this.
Out of infinitely many lines, only one line.
Yeah.
No, there are infinitely many lines and there are infinitely many points, but the infinitely many points are more than the number of infinitely many lines. Sorry,
course.
infinitely many points in that line.
Hmm.
Because for each point where x is equal to y, there are infinite number of points in x direction and y direction which are not x is equal to y.
Yeah.
Which is nothing but saying there are infinitely many points in that x coordinate and the y coordinate which are not satisfying the equation of that line.
Mhm.
I also think that the probability of not the two vectors being not independent is very low.
Exactly.
But is it true? I mean, what Shrivina is saying, I also think on the same grounds that for a line to be present on a plane, the probability is 2, right? That is our argument. But then the notion of infinity comes here as well. So is there
So
anything
some
conclusive?
some
Yeah.
infinities are
Greater than another.
greater than other infinities.
हाँ क्या बात है.
No, if you will consider this matrices of thousands of 10,000s of elements now, in that case, finding this dependency and independence is one of the crucial tasks in calculations. Because if
Yeah.
you don't have something new in the column, then that highly restricts the value of V that you can obtain.
Hmm.
That's why it is crucial thing for us to means,
Yes.
check
It's very
at
important to
this.
understand. Yeah. This is why if you understand null space, you understand whether they are dependent or not. You understand whether you understand independence. Then you understand what is, you know, is the function invertible, right? These things get, a lot of things get clarified once you understand the null space. It's like saying once you know that the function is 1-to-1, you know it is invertible. That was one jump. But I'm saying once you know that the null space is only 0, 0, the matrix is invertible. Obviously, only if it is a square matrix.
Yeah. So now can we reach to the point about saying number of null spaces for any given matrix? Should we go there, or is there anything left?
No, number of null spaces again. Oh, okay. Yeah, we talked about infinite lines and infinite planes. So again, I wouldn't say it as number of null spaces, but I would call it as,
I mean, like possible null spaces, all possible null spaces that I was thinking.
Okay. Before
So
that,
we,
Chittaraja, can you tell me what a null space is now?
That is 0, 0. Like
think about it. What is a null space? I'm asking for any matrix. For any matrix, what is a null space?
so the matrix has to give a output of 0, 0. So that means
Exactly.
it does not
So
contain anything.
So what does it? So try to refine that statement. It has to give out 0, 0. So the function. So when the function is acting, okay. Yeah, maybe refine the statement a little bit. Let's think. Let's see how. So you said the output should be 0, 0, right?
But what should map to that output?
But no. Yeah. Exactly. What is the set of things that map to the output 0, 0? That, I mean, okay, I think I gave the answer, but yeah, go ahead. Try to refine it a little bit. What is a null space?
I basically told you the answer, but yeah.
Yeah, you can maybe, but it's not the exact answer, right? Maybe
Yeah.
a little bit of refining.
Right.
Raja, what is a null space?
So we have defined input. No, actually, we need to get 0, 0 as output, and for that we need to map some values. So that values tends to give a 0, 0 as output. But how to define that?
Exactly. What inputs
give 0, 0 output?
Give 0, 0 output. And how will you define these inputs? They can either be just a single point, which is 0, 0.
0, 0.
Or
it can be a if it is a dependent matrix, then it will have what to say, that other
line or space.
Yeah, space. So space and subspace is okay. If you can use the word space, it's fine. Yeah.
Yeah, okay.
Raja, tell me. Sorry, I didn't get what is the second point.
So I was trying to tell, like, if it is a dependent matrix, then sorry, if it is an independent matrix, okay, so that's what I already wrote, right, for 0, 0.
So you're saying independent matrix will give this. Okay, cool.
Yeah. So one thing is like 0, 0, and the another is like the matrix function itself. So I was basic not mention the input. Like for example, what we saw the -1, -2, 1 kind of input.
Mm-hmm.
So how to tell that in words?
So okay, so
can you
you're saying -2, 1 goes to 0. You're saying this goes to 0, right?
Yes. So one
So
is this value maps to 0, 0 as output, and now one another is like 0, 0 maps to 0, 0. Like
yes,
if the input is 0, 0 also, it will maps to 0, 0.
true,
0,
true,
0
true.
will always map to 0, 0.
That is
Yeah,
the
yeah, that's what.
property of a linear transformation. That is a property of matrices. Okay.
Yeah.
But when you said, so what will be the second point, right? What if this,
-4, 1, -4, 2 will also lead to 0, then 0.
Yeah,
So
so the
what
span
you have
connecting
is
the
a
0, 0 and -2, 1
so span of,
line connecting.
Correct. There you go. Bingo.
and what is that span?
set of vectors that map to 0, 0 is a null space. Chittagong?
So
Did you get it?
set of vectors or set of points.
Oh,
Yeah, you can.
Set
what
of
is a
points
span?
present
What is
in
a span?
span
Isn't
is
it a
like
set?
entire line.
So that is a set of vectors, right? A set of vectors in a straight
Vector in the
in
sense it is a direction, right? It's just a direction.
so
Mm-hmm.
But
you have
points
Okay,
means
okay.
points.
Are you
Yeah.
I mean, are you a science student? Like,
Mm,
have you been
mechanical.
using vectors in physics a lot, maybe?
No.
No, is it?
But
Then
in
what?
in my CAD related work, I used vectors.
Yeah, so okay. So in mathematical sense, when you see a vector, I just defined it for you, right? What do we see when we see a vector? I didn't say anything about I mean, see, we literally saw that 1, 2 when represented as a point can also be represented as this, right?
Yes.
I mean, at least it's going in the same, it's ending up in the same place. Though the representation here is a vector and here is a point, it is nothing but doing 1 times x and 2 times y and 1 times I hat and 2 times j hat. Why? Because x is nothing but 1, 0. Actually, you can think of points represented as a linear combination. You know why? Because it's nothing but saying 1 times 1, 0, which is x, plus 2 times 0, 1,
0, 1.
which is y. This is the same thing that is represent here, but because we don't want to do this in, I mean, we want to represent it in a better way. We don't want to use the same concept.
Oh,
So that's why
what
we can
Chetan
use
meant.
points and vectors. I'll just finish this point. We can use points and vectors interchangeably because we just want to say, we just want to represent a point in a 2D space, right? Or a 3D space or 4D space. You can do that as a point or you can do that as a vector. But when you think of a vector and you think of scaling a vector, you can't scale a point. I mean, we can technically, but I mean, we're not used to thinking of it that way. We want to you know, we wanted a better representation of it, so we thought of vectors, right? Because they have like a, yeah, they have a better representation. So scaling vectors is easy. Scaling vectors is just moving along, moving the, I mean, 2 times the vector is doubling the vector, like things like that, right? Putting the vector on top of each other. You can't put a point on top of itself, right? That's why we got the notion of vector in mathematics, which can interchangeably move between a point and a vector. But the advantage of using a vector is that you can scale it and add it. Do you want to ask anything or anything that you're confused about?
Not waiting
Sure.
for something.
See,
Yeah,
in this,
that's
in
all.
the,
Oh, it's good.
in the, in
Anyway,
the,
definitely I will. Yeah.
in the question that we are dealing with, Chetan said set of vectors mapping
To 0, 0.
to
0,
0,
0
0.
and minus 2,
So
one, right?
Is null space.
no, minus, do not go to -2, 1. In this question, -2, 1, that
Yeah.
set of vectors would lie on that line which constitutes from 0, 0 and 2, 1, -2, 1.
-2, 1. Right.
So what you actually initially did is that imagine a set of vectors, every possible vector in all possible direction that maps to 0, 0. But no, that is
No.
supposed to be only on one line that connects that
See, you cannot have multiple and how you are thinking, right? Is that infinitely many lines mapping to 0, 0. You cannot have that. What you're going to have is a line that is mapping to 0, 0, like we have here -2, 1 and 0, 0. But on that line, you have multiple set of vectors that are mapping to,
infinitely
yeah,
many vectors to be precise.
yeah, exactly. So that is what I meant when I said set of vectors mapping to 0, 0. That's another way of saying the same thing. Span of vector mapping to 0, 0. Same thing.
But we don't need to mention that like value because like for example in this example -2, 1. So whether we need to include that for the definition purpose, like set of vectors mapping
It's
to
up to
0,
you. It's up to
0.
you. How do you want to define it? Okay,
So
There
he's
are
saying,
many
May-
there are many ways of saying the same thing.
right.
Whether
It's-
whether you use the word span, whether you use this fancy way of saying a set of vectors, and that is understood that set of vectors would lie on that line only.
Yeah, you can say the line is so.
You can say that a line connecting these 2 points.
Main thing is that you should understand what a null space is. You can define it however you want after that point, after you've understood what a null space is. But the main thing is that you should understand that it's a set of vectors, it's a line, it's a subspace, it's a span of a vector that's mapping to 0, 0. That's it.
A set of points, you can also say if
Set
you
of
can
points
plot it.
if you wish to.
that is actually the best definition, right? Because when we think about inputs, they are
Points, XY.
points, right? But also when we input as vectors. So this is also right. But actually, when he said it feels incomplete, I understood him because we didn't specify what set of vectors. Those set of vectors have to lie along the
Do
line.
you have any other set of vectors that are mapping to 0, 0? If you have, that will also be part of this null space. But if you don't, then you only have a set of vectors on that line itself. So
What
it's
is a set of vectors? I
self-explanatory.
want to understand. What is a set of vectors?
So
guys, you know, we will miss our next target in next coming 5 minutes.
No. I just want to understand this. See, is this not a set of vectors?
Yeah. But is 3, 4 mapping to 0, 0 in this case or not?
Yeah, but that is not put. The condition is not here, right? That's what
No,
I am trying. Even
See, what I said, set of vectors mapping to 0, 0 is null space. Set of vectors mapping to 0, 0 is null space.
Yeah,
So
that is
after,
true. But
once you
property
specified
of
that,
yeah, true.
once you've specified that, you don't need to specify that it's along a line or you
True.
anything else.
It'll be a
Because-
particular subspace. You're right. You're
Right.
right. Yeah, that is. I mean, that is a point we all want to. That level of understanding we all want to reach. I just wanted to take it step by
So-
step. I think Raja is right. Right. He meant so. Raja, what they are trying to say is once you find the set of vectors that
Maps to 0, 0.
that go to 0, 0, it'll actually be a line passing through 0, 0, or a plane passing through 0, 0, or the point alone, right? It can only be a subspace. Right? So they're saying once you find that set of vectors, you will find the underlying subspace that it belongs to. That's all.
And that's it. That's a null space. That's it. That's
Yeah.
the whole story of null space.
Oh my
I
god.
hope you understood what null space is.
Theoretically or actually?
I mean, both. I mean, if you still have. Mhm.
Theoretically, I have some imaginations like about null space.
Mhm.
So it is a like very minimum thing. Like we cannot define it as a space or anything. So it is approximately or equal to null or
See,
something like that.
How
There is no.
you
No,
know
no,
the
in linear
natural
algebra.
numbers, right? See, you know what natural numbers are, right?
Yes.
In those natural numbers, you have a group called prime numbers.
Yes.
Correct? So that's a specific group whose factors are only one and themselves, right?
Yes, correct.
So you have a whole arena of vectors, infinitely many vectors you have, right? Among those infinitely many vectors, you have a small group of vectors, small set of vectors, which are mapping to 0, 0. That's it. And that small set of vectors is called null space. That's it. You're on mute.
Yeah. I hope you don't forget that null space we are trying to define given a matrix. Don't forget that. I don't want you to think that we're trying to find the null space of. I mean, we're trying to define null space for like everything. We're trying to define a null space given a matrix. Given a matrix, we understand that matrix is a function. It takes inputs, right? And whatever inputs are being mapped to 0, 0, we are calling that set of vectors or that set of inputs as the null space. And the beautiful property of that null space happens to be it'll be a subspace. Actually, that's why it has the term space itself. Anything we learn or we've learned or we will learn soon about row spaces, column spaces, once it's very important to understand that when the term space is used, it's a very, we know what it can lie between, what all it can be. We have a limited number of options, right? We talked about that many times. So yeah. Think about it. You don't have to rush it. Maybe it takes a little time for you. It's okay. Think about it. Ask questions if you have more on the chat, on the Discord group or anything. I'm always looking into the group anytime. You can even DM me. I think a few people will DM me. Do you guys know Anshuman? I don't know. He just randomly DM'd me in Discord and he started asking a few questions and I was like, I don't mind answering. I was actually sitting and thinking about matrices, and I was thinking about vectors, what happens if this happens and stuff like that. And then suddenly he said, texted me, okay, let me answer this question for him.
Nice. Nice.
So apart from this group, there are people who are who are in loop with the linear algebra thing, right?
You have plenty of people on Discord.
Yeah, I don't know why. I mean, obviously, it's not everyone's cup of tea to join
Yeah,
something that is
well,
in I mean, it's not mandatory, so they might just skip it, thinking it's just another activity or something. But
We can stop recording afterwards. I'll tell the couplet.
oh my God, we're still recording, is it?
Yeah.
I don't know who is going to watch these when this long videos,
See,
man.
Rishabh was asking me for the recording. My God, God bless his soul. He'll have to go through all of this.
I don't know how people. I don't know who is
But,
going to benefit from this.
Chetan, I have a doubt. I have some part of the recordings. Amit has some of the parts. Where should where should we upload it?
So
Is there any Google Drive or something?
you upload it on Google Drive. You share the link.
Okay, then I'll share the link in the group, or I'll share it with Sir. Sir will
Yeah.
post it on the Discord.
Right.
Fine. No worries.
I don't think I. Sorry. Yeah.
No, nothing. Still recording sound.
I don't think I myself will go back and look at those lectures. I'll just come to the next session and be like, oh, what was discussed then? Let's just recap
Yeah,
it.
exactly.
Even I
guess
think that
these links are for people who will be joining late. So
yeah, exactly.
they'll be the
So
ones
Sir
who will.
yesterday was saying that sir yesterday said that we should create a a good quality resources, right? We have to create good quality resources.
Library
So
of
we have the
resources.
notes and we have these whiteboard PDFs and all. But if there are the recordings, as in when we move further, after 2-3 months, there will be people who just begin with all these concepts. They'll watch, they'll see the notes, they'll solve the questions, they'll see the whiteboard and all, but they'll miss the discussion part. At that time as well, there won't be everyone joining the sessions and discussing. As in,
Yeah, I understand.
there would be a
But
group.
really, I totally understand that entire point. Right? Like how I joined late in Codesai. I was not.
Yeah.
I was a bit
No,
late. Right? I think I joined
this
only.
won't be. I'm just raising a point here. I'm not sure that it would work. People will watch these so long sessions and all, but yeah.
Now,
Not sure.
I would
This
like to
could
put
be a
a
thing.
caveat to that. I'll be traveling to Roorkee in couple of days. I'll
Okay.
have to watch recording in that case while I'm traveling on traveling days. If they do
Oh.
not, or maybe if they give us, if they allow us to use their Wi-Fi, maybe then I'll be present. So it will be very beneficial for me, at least in those days.
Understood.
Yeah,
understood.
right.
That is also a very good use of that.
But there's
Yeah.
one thing we need to.
Nobody will understand our whiteboards. Look at this whiteboard. Some people will think we are crazy, right? Literally, they'll be like, "What is this nonsense they've written?" It's like encoding has been done, decoding nobody can do. I don't think I can
True.
do after 2-3 days.
Yeah, exactly. After time. But yeah, there should be some regulation on these videos before everyone sees them, I guess. Because it is too
These
huge
notes
content.
and these notes and videos needs
Video
processing.
specifically for videos, though it should
So
be.
Rishabh goes through all of these. So he's the one who's
Acha.
editing videos. That's why I pity that guy.
Editing videos.
I pity that guy.
We all should take that task then.
I mean,
Oh my God, I can't go through this again. Already 5 hours. And my head is already like, what will this happen? I am done. I'll become a zombie, man.
Yeah.
Janab, Rishanur साहब, Irshad,
अच्छा. So उसके पहले मैं एक caveat दे देता हूँ. The caveat is that there is a concept that what we are, we have two parts. One is our soul and another is our body. Body is very temporary, soul lives forever. Fine. So, and there is a greater soul. From there, comes the concept of Atma and Paramatma.
Hmm.
We are Atma and Paramatma. So, I
Yeah.
guess I don't remember the name exact. I guess it is Ghalib only
Hmm.
that says that कुछ ना था तो खुदा था.
Hmm.
What is
Yes.
Kudata? I don't
Khuda
remember
is
that.
Khuda is
God, God.
So what
Kuch-
it means is when nothing was there, it was
God.
God.
or- Okay.
the
God
God
was
was कुछ ना होता तो खुदा होता.
Hmm.
बिग बैंग नहीं होता तो था तो होता वो. डुबोया मुझको होने ने. मैं ना
शायरी?
अगर मैं ना होता तो क्या होता.
वाह वाह
Hi,
वाह
hi, hi,
वाह
wow.
यार वाह यार.
नल स्पेस
I
होता और
missed
क्या होता.
that Big Bang ka line. Yeah, I missed many of the lines. I missed the joke. Please repeat it. Yeah.
He said, try relating to null space. Try relating this to null space. I remember this, this couplet for time immemorial. This is since I am alive. So, so suddenly it clicked to me. Okay, every line of this couplet points to null space. That guy somehow knew this. This is a very famous, line. These lines are very famous lines.
Hmm.
I'll repeat it. That कुछ ना था तो खुदा था, कुछ ना होता तो खुदा होता, डुबोया मुझको होने ने, मैं ना होता तो क्या होता. नल
Wow.
स्पेस होता और क्या होता.
Space with our God.
Null space.
अरे
Origin.
लाइन
So-
बन के भी क्या हुआ उसका, वो तो गया, वो नल स्पेस ही में गया ना.
My God.
वाह.
Okay.
This null space, man.
I doubt. Okay. Well, Chittu Raja, did you understand the couplet?
Please translate
Yeah.
it in English for Chitta
शायरी
Raja.
शायरी. ये शायरी है क्या? Is this a शायरी?
Yeah.
हाँ,
So,
this is from
Mirza
Ghalib most
Ghalib.
probably.
Yeah, Mirza Ghalib is like the
Yeah.
was stud of shairi. Okay, that guy, the kind of attitude that guy had, right?
Mhm.
It's, I mean, nobody matched after him. That attitude. Okay,
Maybe I should watch.
And there is a very famous story about him. He was so, he was. क्या-
Recording stop
how-
कर दें?
हाँ,
I
of
don't
course,
think we're going to
of course, of
discuss
course.
enough.
Okay,
Uh-huh.
just let me rejoin.